With all the basic knowledge we gathered, it's now finally time to also work with the HTML document our script is running on our own. Because thus far in all the tiny projects we worked on, I always gave you that vendor.js file, that black box code, which in the end established connections to certain elements in the HTML code. Now it's time to fully understand how we can establish such a connection, because there's more than one way of doing so, and how you can in general work with the HTML page that was rendered, manipulated, and so on. Specifically in this module, we'll have a look at the HTML code, how it's loaded, something which is called the DOM and what this means, and how JavaScript fits into the equation. We'll have a look at nodes and elements, which are two important types of objects, if you want to call it like that, with which we're working if we're working with the HTML content through JavaScript. We'll have a look at how we can query DOM nodes, so how we can get access to parts of that rendered HTML code, and how we can move around there in JavaScript to select different elements and do stuff with these elements. Because we'll also have a look at how we can read and manipulate the DOM, so how we can, for example, change the style of an element or anything like that. And of course, we'll also have a look at how we can add brand new elements to the rendered HTML page, or how we can remove such DOM nodes, which will turn out to be HTML elements. So a lot of content in this module. Let's not lose any time and jump right in. You heard me say DOM, or refer to something called the DOM on the last introductory lecture here. Now, what is that DOM thing? For that, let's understand what the browser does with the HTML code, which is part of any web page we create, and how JavaScript works with that. So we got JavaScript and we got the browser, these two pieces which interact all the time. And now let's say on our web page, where this JavaScript code is loaded eventually, we also render this basic HTML code. Now, of course, we also have a head in our HTML code, but let's say this is what's in our body there. So what actually happens is that when this HTML file, that HTML document is downloaded, the browser goes over it and parses it and renders it. And I showed you this earlier in the course already when I showed you the different ways of loading JavaScript files and how that affects the parsing of the HTML code. Because the browser simply reads that HTML file from top to bottom, and when it encounters a script, it executes it. When it encounters other HTML elements, it simply parses and renders those. And in the end, it then renders the pixels on the screen, which you need to see a button, to see a title, and so on. So that's what's happening here. Now, JavaScript might be part of that web page. It certainly is in all the web pages we work with in this course, and it's loaded by the browser. Now, don't forget that JavaScript is a hosted language. I mentioned this in the first course module. That means the browser provides the environment for JavaScript to run. It provides the JavaScript engine, which in the end parses and understands all the JavaScript code and executes it in the end. So the browser provides that. It also provides a bunch of APIs, a bunch of functionalities into which JavaScript can tap, so that JavaScript can interact with the browser. We also saw that already, and it will become super important here now when we work with the loaded and rendered HTML code, because the browser actually exposes functionality to let JavaScript interact with that rendered HTML code. And in the end, that's called the document object model. The abbreviation, of course, is DOM, and that's where this term comes from. So the DOM in the end is this loaded and rendered HTML code, or to be precise, the object representation of this code which the browser creates behind the scenes, into which we can tap with JavaScript. So JavaScript can work with a bunch of objects which will be exposed to us as JavaScript objects, which in the end represent what the browser rendered or what the browser made of that HTML code which was provided. And in JavaScript, we got certain methods, certain functionalities, like here, this document query selector code, that allows us to reach out to that loaded HTML code. And for example, with this code snippet, which you see here, get access to the first H1 element we have in the loaded HTML code. And of course, you'll learn about all the different ways of querying HTML elements and how to configure them in this module. I also briefly want to mention that the DOM is not strictly tied to browsers. There are other tools which can also parse HTML. That's not even restricted to JavaScript. So in other languages like Python, you also can find certain tools or certain plugins, extensions, which allow you to read and work with HTML code, or also with JavaScript if you're running it through Node.js, let's say. That does not have this DOM functionality built in because you typically use it on the server side, or it's, well, simply detached from a browser, but you can still add certain packages to kind of bring that back in and still be able to parse and read a HTML file. The browser, however, has that all built in for you. And in the end, it has two important built-in global objects, you could say, which kind of grant you this access. And we can see one on this screen already, this document object here in the end, which is globally available, which is not created by you, but which the browser exposes to you to give you access to all the different ways of interacting with that HTML page. Now, I mentioned the document. This is one important piece in working with the loaded HTML code. There also is another important global object, and actually document is a property of that other global object, and that's the window object. Now, the difference is that document in the end is the root DOM node which the browser exposes to you. That means that this is really the topmost entry point to get access to all that rendered HTML code. So this provides you various methods and functionalities to get access to the elements, to query for HTML elements, to interact with the DOM content, so to interact with the loaded HTML code. Window, on the other hand, is a global object which, as I just said, actually has document as a property. So window is the real topmost global object made available to you in JavaScript in the browser. And that in the end reflects the active browser window or tab, if you want to call it like this. So it's basically your global entry point, your global storage, if you want to call it like this, for your script. So it gives you access to all the features that the browser wants to expose to you. The root entry point is always that window object, but it also gives you some window specific properties, for example, for measuring the window width or anything like that, which we'll also have a look at throughout this module, of course. Now, before we actually start to work with any HTML elements, let's have a look at that document and that window object. Now, for that, attached you find a very basic starting project, essentially an empty HTML file and an empty app.js file, which is imported into that HTML file here. And if you open up that HTML file and you open up your browser developer tools and go to the console there, which allows us to also run some JavaScript commands, as you learned, then here you can simply write document, and this gives you access to this document object. Now, by default, you'll see you get this strange representation, which looks like HTML code here. That's a little feature by the Chrome DevTools. This is actually a JavaScript object, but since it's tied to that loaded document, to that loaded HTML code, it gives you this representation where you can even select different parts if you hover over them. But to get a feeling or get a look into the real JavaScript object, you can type console.dir document, and you can use console.dir in any cases where console.log gives you this strange output in the DevTools. And now you get access to the real JavaScript object with all the properties that are in there. And you see there are a lot of properties in there. Now, most of them might never matter to you. But for example, the body property here, if you expose that, gives you access to an entire new object, which in the end reflects your document body and everything that's attached to that. And this will also allow us to get access to all the HTML content rendered in there. There are other properties which you can dive in. For example, document element here is basically your entire HTML content. So the body gives you access to everything that was rendered in that body part. HTML holds everything that was rendered or set up for your entire HTML code which was rendered. So that's also another important property. We also have a couple of other important properties. Head, for example, unsurprisingly gives you access to everything that was rendered as part of this head. So together they kind of make up that entire HTML code as well, of course, and so on. So there are a bunch of interesting things in there, and we'll work with a couple of them, but there also are a lot of them which you will never really need. But of course, feel free to browse through all of that in that document here. This in the end is one of these important topmost objects which are made available to you by the browser to allow you to interact with your loaded HTML document. Now let's clear the console and let's also output window here. So you can type window here and you get access to that window object. Now this is that real topmost object, and this gives you access to all the core APIs that the browser wants to expose to you. And for example, here you also find alert, a function which we already used a couple of times in this course to throw such an alert. The important thing is that with window, you by default, if in your JavaScript code, if you're typing some code here, you by default have access to everything in window, which is why you can't just type alert like this. Totally correct would be window.alert, as you see, because window is this topmost global object which is exposed to you by the browser, and there you have the alert functionality. But actually, browsers always parse your JavaScript code such that window.dot is automatically added in front of some function if that function can't be found anywhere else. So the browser always looks in the window object if you're calling or accessing something, which is why alert works just as well as window.alert would work here. So that's really great. So that window object is a really important global object giving you access to all these browser APIs like alert, a bunch of other things which we haven't worked with yet and which we'll see later. And also the document here. This is the document I just output a second ago. It's part of that window as I mentioned. Now, but as I also just mentioned, if you enter something just like this, the browser automatically looks in the window, which is why we could use console.dir in the DevTools, and we could also use it here, because that will automatically look in window.document. So you could use window.document, but you don't need to. The same for the alert. So that's that document which we have in here. Couple of other nice features which we'll see throughout the course here to store data in the browser and so on. Couple of events which are exclusive to the window though, which fire when certain things happen in the window. And these on something events here, by the way, are just alternatives to using add event listener, something I'll dive deeper in the events module of this course, where we learn all about events and how to work with them, and so on. So there are a bunch of interesting things here. For example, with outer height and outer width, you see that this gives you certain dimensions about the window in which your app is running, your script is running. And also always keep in mind that window does not really give you access to the real window, but also just to the tab in which your script is running. So you won't be able to use window to interact with a totally different web page loaded in a different tab, because that would be a huge security issue if you could start reading information from another tab on your web page here. That would not be something you would want to do, because you could fetch important information from other tabs. So whilst it's called window, it really just means the currently loaded tab, but also the dimensions of the general window and so on. That's how you can think of it. So that's window and that's document. And no worries, we'll work with more of these things throughout the course to also see how we can get the size of the web page and so on. For now, it's just important to keep in mind that you have these two global objects, or that document actually is a part of the window, but that you can access it with just document due to the way how window works, and that this will help us interact with the web page and with the loaded HTML code. And with that, let's dive deeper into that DOM thing and understand how the browser really translates the HTML code to something and how we can then interact with that. So let's have a closer look at that DOM thing, at the document object model. Consider this HTML code. This would be some valid HTML code, which in the end renders a very simple web page. Only the doc type thing at the very top is missing here because it doesn't really matter to the browser and to JavaScript. But this contains a head with a title. It contains a body with a header with the h1 tag, and then a main tag with a paragraph tag. So a couple of default HTML tags which you can use in your HTML documents, which are understood by the browser and which will be rendered to the screen. Now, what the browser does in that case is it, of course, renders all the pixels, but it also kind of parses the HTML code and creates an object representation of that, because behind the scenes, the browser doesn't work with text, which HTML is in the end, but with these objects that are stored in memory. And there, for example, the HTML tag is translated to an HTML node, as it's called. And this is an element node, to be precise, because that in the end is a node, and these objects are simply called nodes, which represents an HTML element, an HTML tag, and therefore it's called an element node. And such element nodes are created for all the HTML elements you see on the left. Now on the right side, the main and paragraph node is missing because the slide isn't big enough for that, but you get the idea. Now you also already see I'm creating kind of a structure here. These blocks on the right are indented on different levels. And the reason for that is that in the end, the browser creates a tree of elements, or a tree of nodes, I should say here. And in that tree of nodes, the HTML node is the topmost node. It has the head and the body as child nodes. The head node has the title as a child node, and the body has the header node as a child node, which in turn has the h1 node as a child node. So in the end, the relation you see in your HTML code on the left is reflected in the created objects as well. So the browser keeps track of the parent-child relations you have between different HTML elements, and it does keep track by creating such a node tree in the end. Now, important to understand is, however, that not just HTML tags are loaded and created as objects, but also all text that you have. And these are created as so-called text nodes. And that might already be strange what I'm pointing at here. This empty white space here in front of head is actually translated to a node in the browser. This is part of the loaded node tree. So this here in the end is a line break, which I try to reflect here with this pipe symbol on the right. And then we have two white spaces here with the two underscores on the right side in that text node. Now, typically, you don't see that on the screen because due to the way styling works and so on, most white space is actually not rendered, but it is part of that DOM tree, of that node tree in the end here. So it's part of the DOM. But of course, also the normal text is part of the DOM as text nodes though. And these really are two different types of nodes. You have element nodes for all the elements which you have, but then the content in the elements might be other elements, but might also be text, and text is indeed stored as objects, but as a different kind of object, as text nodes with different properties and different methods. So this is how our HTML code would be reflected by the browser. And to get a better feeling for that, I'd suggest let's have a closer look at this in our web page. For this, back in the index.html file with which we started, I'll add a header here in the body, and then a h1 element in there where I say dive into the DOM or anything like that. And this very simple HTML code is therefore already a valid HTML file, which of course is loaded and rendered by the browser. So if we reload this page, we now see the h1 tag here, of course with no real styling other than the default styles the browser assigns, but still, this is some rendered HTML content. And now to get a feeling for what the browser rendered there, you can always go to the Elements tab here in the browser DevTools in Chrome, and you see in the end the loaded HTML code, but this is basically also what the browser loaded as a DOM, but of course reflected still in human-readable HTML tags and not in some object names. Still, this is in the end what the browser loaded here, and this is what you can interact with. And in the DevTools here in Chrome, you can even hover over things and they're selected on the left so that you can see where they're at. Or you use the selection tool here at the top and click on an element, and then the respective DOM node on the right is selected, which is also pretty sweet. Now, you might also see that part here on the right, that $$0. That's a little convenience feature which the browser gives you. If you now hit escape, the console should open up at the bottom. Of course, you can also go to the console tab as an alternative. And in there, if you type $0, you get access to that h1 element. And that's now just a feature here in the browser, not a default JavaScript feature, just a feature here in the Chrome DevTools to make it easy for you to select elements. And if you For example, type console.dir $0. You print that h1 element, or you get access to the h1 element object here, and you can dive into it, and you'll see a bunch of things. For example, if you scroll down to T, you'll see that text content element here, which in the end holds the text in there. And that is an example for that text node, which is rendered in there. Now, speaking of text nodes, what you don't see in the Chrome DevTools, and you can dismiss this console by hitting escape again, what you don't see here is, in the end, the text nodes. You, of course, see the text where you have real text in there, but white space is not displayed as a separate node here. So that's not something which is shown here. Still, it's important for you to understand that such text nodes are created, and we'll see them later when we do actually programmatically query elements from inside our JavaScript code. So this is a DOM node, and here, by the way, in the DevTools, you can even edit this on the fly, which will not affect your file here, but which you can do to try out different things and change things here. You can even change the type of HTML tag and so on. So that's all possible, but that's not really the focus of what I want to do here. Instead, let's now see how we can actually query these things from inside JavaScript to work with the DOM here and with these nodes from inside JavaScript, and then maybe also change some things from inside there. Now, to query elements or nodes, and I kind of use this term interchangeably, though I will come back to the difference in a few seconds. But to query content, let's say, in your HTML page, or in your rendered HTML page, so in the DOM, you have a couple of methods which you can use on that document object I showed you a few minutes ago. Most importantly, you got query selector and get element by ID. These methods will select one element at a time. You also have query selector all and other methods like get elements by tag name, which will select multiple elements. So you can get access to single elements with query selector and get element by ID. And these are simply different ways of querying elements. Query selector takes a CSS selector, as you could use it in a CSS file. Even pseudo selectors are supported, and gives you therefore a lot of flexibility and power when it comes to selecting elements with complex query in your DOM. Get element by ID, on the other hand, takes an ID which you might have assigned to an HTML element and selects an element by that. And since IDs should be unique on your web page, this is a method which returns one element. The query selector method takes any CSS selector, and therefore this might be a selector that matches multiple elements. But in this case, query selector, this method will always give you access to the first matched element on the page, so in the DOM. So this gives you a direct reference to this DOM element which it found. Now, query selector all, get elements by tag name, and there are other methods as well which I'll show you, give you access to collections of elements, array-like objects, typically a node list, though that also is not always the case, but typically it's such a node list, which is not a real array, but array-like, so which supports certain behaviors of an array, but not all of them. You have different ways of querying elements. You can, for example, use the above methods. Query selector all takes a CSS selector as query selector, but unlike query selector, it does not return the first element which it matched, but all elements that match the selector. Get elements by tag name, give you all the elements that have a certain HTML tag. And then there are other selectors to select by class name or by the name attribute which you might have assigned, though the query selector all method is the most flexible one, where you have the power to select anything you want by CSS selectors. Now, one important difference here, which I want to mention right away, which often will not matter, but still is worth being mentioned, is that query selector all will give you a non-live node list, so a snapshot of the currently rendered DOM, whereas these get something by something methods, like get elements by tag name, return a live node list, which means that if you then add or remove elements, which we'll also learn throughout this module, you'll see that reflected in the list which you loaded through the get something by something method. It will not be reflected in the data returned by query selector all. But again, that's something we can come back to later once we learned how to add and remove elements. For now, let's ignore that. Before we try these methods though and play around with them a bit to get a feeling for how you select things, let's dive into nodes and elements. I kind of use these terms interchangeably, but actually you should be careful and you should at least understand what the difference is. So you have nodes and elements, and nodes are the objects that make up the DOM. Everything in the DOM is a node. HTML tags are just element nodes, as I mentioned. I will also refer to them as just elements, but in the end, these are element nodes to be super precise. We also have, for example, text nodes, and there are other nodes as well, which aren't really that important though, and which with you'll not really work. Attached, you'll find a thorough document about all supported nodes, but text nodes and element nodes are the important ones. Now, elements, therefore, are in the end just element nodes, as I just explained. So elements are really just the nodes which are created off of HTML tags which were rendered, not the text in there. Now, why does this matter? Because on element nodes, on elements therefore, you have special properties and methods to interact with the elements, to change their style, to change their content, and so on. You also have special properties on methods and text nodes, but you simply don't work with text nodes as often as you will work with elements, because typically you want to add a new HTML element. You want to remove one, you want to change the style of one, you want to edit it in any other way. For text, you typically just want to change the text, and then you typically just go to the element that holds the text and change the child content, which is the text, of that element, which is why you don't work with text nodes as often. So which exact properties and methods are available on every element, so on every rendered HTML tag, depends on the kind of element though. For example, on an input where the user can enter content, you have ways of reading that input. On other elements where users just can't edit the content, you don't have access to that, of course. And you have different ways of selecting elements. As I mentioned, we'll learn about different methods that give us access. And you can also create and remove them with the help of JavaScript. So that's the difference between nodes and elements. Elements are the important thing for us here. Text nodes are most of the time just created automatically when you set the text content of an element to a new text content, for example. But again, it is something we'll come back to. Let's now try out some of these query methods to get a feeling for how they work. So here's the loaded web page. Here's that rendered DOM represented in an HTML-like language, but in the end, this is what the browser parsed. And now let's play around with some of these query methods. For that, I also want to be able to select multiple elements. So we'll actually also add an unordered list with some list items where I say item 1, item 2, and item 3 so that we can select by them. I also will give the item 2 and 3 a certain class, list-item. You can of course use any CSS class name you want here. And I'll also give that h1 tag here an ID of main title maybe, so that we can play around with the different ways of querying elements. So with that, let's save that and reload and now play around with these selection methods. Now for that, let's go to the console window here. And now all these query methods are available on document, so on this document object, or actually also, and that's really important, on any other element node which you selected. I'll show you what I mean in a second. So let's select this header, this title here, this h1 element here. And let's start with selecting it by ID. For this, you can use document, get element by ID, written like this. Make sure you get the casing right. And then as an argument to this method here, you pass the ID here, in this case, main title. Now important, just main title like this. No hash symbol at the beginning, because this would be your CSS query selector, but we don't need that here. Just the ID name. If you do that, now we get this strange output here again, but I can hover over it and we see this seems to work. To get a feeling for what's in this object, we can also use console.dir and then document get element by ID, main title, close all parentheses, and now we have this JavaScript object which we can inspect. Now this is the object which the browser automatically creates and exposes to us in JavaScript for this h1 element. And such objects are created for all rendered HTML elements, so for all tags that you could have there. Now there you find a bunch of information here. For example, class name would list any CSS classes that are added, none in this case. The position and the size here in the end, so where is it positioned in the window, what's its height, what's its width. The ID which was assigned, and you can also manipulate most of these properties here, as I will show you soon. So that's all something you can do. The inner HTML, so any nested HTML code, which in this case we have none, so here it's just the text which is in there. And also quite interesting, if I close this, if we store that in a variable, which I could name h1, the name really doesn't matter. Of course, it doesn't have to reflect the element name you're about to select. So if I store this in h1, I store the selected main title in there. It's also interesting that on this h1 element, you can again use certain methods. For example, query selector or query selector all. Get element by ID is actually not supported here, but all other selection methods are basically supported as well. So the idea simply is that with document and then some selection method, you search in the entire document for an element by class name or with a certain CSS selector. But then once you have one element and you want to search only in the child elements, in the child nodes of that node, I should say, then you can use that element itself, like this h1 element, and then use the selection methods in there to only search the child nodes in that part of the DOM tree. So only in the h1 element, for example, where we won't find any, but that's something we know here. Of course, if we would search other parts like the unordered list here, then we could search its children for having a list item with this list item class, for example. So let's have a look at more selection methods here. For example, again on the document, we can use this get elements by class name method here. Now this is a pretty old method, but still supported and still fine to use. And there we can, for example, search the list item classes here. So here indeed you just enter the CSS class name like this, and this will return a so-called HTML collection object, which in the end is like an array, not a true array. Not everything you can do on an array works there, but you can, for example, use a for loop with this for let I syntax and so on to search through that array and select elements by index. And this gives you access to all the items, all the nodes that have such a class name. Now, more common these days is a different selector though, and that would be query selector. So if you want to select an element by a class name or by tag, you typically don't use these older methods, get elements by, but instead query selector. Get element by ID is one exception. There you typically use get element by ID if you want to get an element by its ID, because that is a unique element on the page. But if you want a collection, or even if you want one element but with a more complex query potentially, query selector is the way to go. And there, for example, to select all items with the list item class, you would also type list item, but now important, here you need a selector as you would use it in a CSS code. So there, to select a class, you add a dot in front. An ID would be selected with a hashtag. This would look for elements with a tag of list item, and so on. So you can search for .list item, and now query selector, as I mentioned on the slide, will return the first matching item. If you want to have all matching items, you use document query selector all, and then enter your CSS selector in there. And this will now give you a node list, also such an array-like object, which you can basically work with like an array that gives you all the items it found for this selector. And the selector here can be complex. You can absolutely also use query selector here to, for example, look in the unordered list, and then for a list item, and then first of type. This would be a valid CSS selector to select the first list item in an unordered list. So a regular CSS selector, nothing fancy here, even using a pseudo selector, as you can tell. And if you do that, you get the first list item. On the other hand, if I would use last of type here, we would select the last list item, as you can see when I hover over it. So that's really convenient. Query selector gives you a lot of power for targeting individual elements on your screen. And you would want to do that, of course, to add event listeners or maybe even to manipulate these elements on the go, because that's the cool thing about JavaScript. It runs in the browser after the web page has been loaded. So it allows you to manipulate what's happening on the screen with that already loaded page, which allows you to create highly dynamic user experiences where you can change things on the UI without the need to reload the document or to load a new document. Instead, you can change the existing one, which provides a faster and better user experience than if the document reloads on every click. So that's a really powerful thing about JavaScript. And with query selector, get_element by ID, and these other methods, we have different ways of selecting elements. And of course, we'll select elements very often throughout this course here, throughout this module, but I hope you now have a solid understanding, a solid overview of the core ways of selecting elements and what the core philosophy there is. Also, always keep in mind that you cannot just use document to select elements. That will just search the entire document, so the entire head and body, but that if you already have an element like your unordered list, so if I query selector by UL, and I store this in a constant UL, that you then always can use this element which you already selected, this element node, and there you can also search for query selector and now list items. And this will now only search for the first matching list item inside of that unordered list and nowhere else on the document. So this is also something you can use, and this is how you query elements in the document, how you get access to them in JavaScript. As you see, you can store them in constants and variables, and this allows you to work with them. Now, really important for this entire DOM querying and manipulation stuff is that you import your script correctly. I already explained all about this earlier in the course, I just want to emphasize it here. You need to import your script such that it only runs after all HTML content has been parsed. That can either be achieved by putting it to the end here, like that, then it works even without the fur, or as I have it here, by importing it in the head, but adding the fur here, which means download it early, but only run it once you're done with parsing. Because otherwise, if you don't have the fur here, the script might execute too early and therefore might try to query for elements which haven't been parsed and loaded yet, which of course will not work. That's really important to keep in mind here. So we selected an element in the DOM or multiple elements. Now we want to manipulate them. That is not something we have done too often in this course. Sometimes, like in the monster killer, when we changed the health bar that's rendered on the screen. But it is something you typically want to do a lot in JavaScript-heavy applications where you want to provide that good user experience to the user, where you change things in the rendered user interface without the need to reload a new page with that changed HTML code. Instead, you want to change it in the already loaded page, since that is just faster and provides a smoother experience than loading a new page. So let's say we have a paragraph here with an ID and a CSS class and some text in there. And we selected this, for example, with get_element by ID, which we can of course do with that welcome text ID it has, and stored it in a constant. And now what can we do with that? Well, for example, we can read its text content, welcome in this case. And we do this with the text content property, which this exposes. We can also read the ID by accessing p.id and get ID as a string that's stored in there. Or the same for the CSS classes with the class name property. So important, not .class, but class name, to get access to the CSS classes that are assigned as a text here on the element. So that's how we can read data from there, something which you also want to do a lot. You don't always immediately change things. Sometimes you also just want to find out in which current state is this element, which CSS class does it have. But then you can also change this by, for example, assigning a new value to class name. Not all properties of an element are writable, but a lot of them are. And then you can assign a new text here, and this will be reflected back in the DOM, which the browser rendered, and will of course be updated on the UI, totally automatic by the browser. So let's have a look at that. So back here in our playground, let's say on that header here, on this h1 element, I want to change the text color and the background color, and maybe also the text which is shown in there. Well then, first of all, we can get access to it. I reloaded the page for this, and now I'll create my h1 element with document, and to mix things up, I'll use query selector h1 here. We could have used get element by ID and used the ID, which this h1 tag has, the main title. And now this is stored in h1. This is storing a reference to that DOM object which the browser exposes to us. Now here, for example, we can read text content and get the text which is in there, or class name to get that CSS class string which is assigned to it, which currently is an empty string because indeed we have no classes assigned here. And of course other things as well. Now let's say we wanna change the text, and for this you can simply write text content equal and then some new text, for example. And if you do that and you hit enter, this changes here on the screen. And what this does behind the scenes is it removes the old text node that was in there. Remember, it's a node, just a text node, and instead created a new text node and replaced the old one with it. So that's what happened behind the scenes. Now we can also assign a new CSS class by setting class name equal to title, for example. And if we do that and we go to elements, now we see the class title on there. And if we now had some CSS code that would assign a certain style to that, we would see that. But since we don't have that, let's change the style in a different way by reaching out to h1. And then there is a style property, which in turn gives you access to a huge object with all these CSS styles you can assign to an object, just now translated to JavaScript properties, you could say. So for example, there you can set the color to white or to a hex code. And now the text is white, which makes it quite hard to read. So let's also change the background color by going to h1 style. And then important here, background dash color would not work because this is not a valid property name. You must not have dashes in there. So instead, all these CSS property names that have a dash in there are translated to JavaScript property names, which are generally the same, but where the dash is removed. And to make it more readable, therefore, the first character after the dash, so in this case the C, is replaced with a capital character. So background dash color becomes background color like this. And now we can either read it, well, there's nothing in there because no value has been assigned, or assign a value, for example, red. If you do that, you indeed see the red background, the white text, and so on. So this is how you can work with the properties on these elements and also manipulate them. Now, of course, you might wonder, how do I know which properties are available? Well, for one, don't forget you can always console.dir h1 and then simply dive into it. That is something I would recommend that you absolutely do, because whilst there are many things which you won't fully understand yet, you can just ignore them, there are many things which you will understand and where you have an idea of where this value might be coming from and what changing it might do. And you can also just try changing certain things. If it doesn't work, well, you can just reload the page and start from scratch. Nothing can go wrong there. So simply just play around with that. But of course, if you want a more official documentation with some explanations, you can always search on MDN, for example, for h1 element, and find an article on that with detailed explanation about that element, of course. And there, important, you'll find the DOM interface. In this case, a HTML heading element. This is in the end just the kind of object that is created automatically. You don't need to learn these by heart, of course. I'll dive into the relation between these different types of elements a little later once we learn more about objects. For now, that doesn't really matter to us. What's important here is you'll find the list of properties which it has and the methods it has. Now what you see here, for example, is that a heading element doesn't really have any specific properties or methods. Instead, the HTML element, which is kind of like a element or an object type this object type is based on, that's the one you want to have a look at. So if we go to that, here we find a more extensive list of properties that is available with descriptions of what they do and so on. So this is something you also always can dive in to learn more about it. But again, good old console.dir and looking into it is also something I would strongly recommend that you also give a try to get a feeling for what's happening there. Now, really important here, by the way, whatever you change here in JavaScript will be lost whenever you reload the page. Because what you do in JavaScript is only stored in memory. it of course doesn't affect the underlying files which were loaded, which typically lie on some server on the internet. So that of course changes. If you reload the page, you load these original files again, and your JavaScript changes are lost. Because whenever you reload the page, this essentially resets your JavaScript application. It clears the existing application from memory in the end and starts a brand new application. So your JavaScript file is parsed again, and any changes you made are not kept around. That's just a side note. When speaking about manipulating elements, it's also important to understand the difference between attributes and properties, because it's easy to confuse these two things or to not even be aware of these two different things. Because often, indeed, attributes are mapped to properties and some live synchronization is set up, and I'll show you what I'll mean in a second. But that's not always the case. For example, here we have an input element with an ID, with a CSS class, and with a value. And that's interesting because there we have three different kinds of attributes which behave in different ways when it comes to the DOM object that is created and how the properties of that object are initialized. So these are all attributes here placed in the HTML code. So what you write in the HTML code is named an attribute. What you add on the HTML tag, that's an attribute of that tag. And what the browser does with these attributes is it creates such a DOM object based on the tag name, input in that case, and pre-configures it and pre-configures some of its properties based on these attributes. Because the important thing is that the attribute is the thing in your HTML code, in your HTML text in the end. The property is a value stored in the object that's created based on your HTML code, so to say, right? Objects in JavaScript have properties, no matter if there are some DOM objects or not. So, of course, for DOM objects, we also have properties, and these simply reflect the configuration and setup and positioning and so on of that rendered DOM node, of the DOM object. And the idea of attributes is that you, if you're writing HTML code, can provide a certain default configuration to this to-be-created DOM object. So that's what you do with attributes and how they are translated to properties. And here, for example, we see that if we get access to this input element and store it in a constant, let's say we name it input, then we can read the ID from it, but also the class name and the value. And the properties, as I mentioned, are automatically added on the created DOM objects. Now here it's important to understand that not every attribute has a one-to-one mapping in properties though. Input ID has it. There we have an ID attribute and an ID property. And if we change the value of the attribute, the property updates. If we change the value of the property, the attribute will update. So we have some live synchronization going on here. Input class name is different. There we also have live synchronization. So if we change the property, the attribute will change. If we change the attribute, the property will change. But the names are not equal, so we don't really have a one-to-one mapping. Class on the input, so on the HTML tag, is translated to a class name property here on the DOM object. And of course, the browser does this automatically. It's just important to note that not always the attribute name is equal to the property name. And for value, we have yet another different behavior. There we have a one-to-one mapping. It's called value as an attribute and value as a property, but we have no real live synchronization going on, only one way. Because what you have here is actually that if you change the input value, this will not be reflected back to the attribute. Only if you change the attribute, the value properties value will change again. And that makes sense because you have to keep in mind that, for example, this input element is there to hold some user input. And if you would always reflect this back to the attribute, then that would mean that if you ever want to reset the input to its initial value, which the developer writing the HTML code at some point of time stored in that value attribute, that this would not be possible if we always reflected the latest user input in the value attribute, because then we could never reset it because we lost the original value we wanted to assign there. So that's why when the user types there, the user's input is stored on that value property, but not reflected back into the HTML code. So let's see that in practice here. And for that, I'll add an input element here actually, with a value of default text here. And after saving this, we can reload. Of course, the coloring here is gone, by the way. So here we have that input element with the default text. And again, of course, we can store a reference to it by using, for example, query selector, and here then just the input tag selector like this. And we can, of course, console dir input here to get access to it. We find a lot of properties which we already know, but if we scroll down to V, we will also find one which is not available on all elements, and that's the value property, which in this case holds default text. Now, if I go to the input here, and in this elements tab here, we change default text by adding an exclamation mark, for example, we go back to the console, you'll see that if I reselect this, so const input 2, document query selector input, and I now console dir input 2, you will see that if we scroll down to the value at the bottom here, we have this exclamation mark in there as well. So if I change the attribute, that is reflected in the DOM object. So that is reflected. Now, if I go ahead and we set input2.value equal to some other input the user might have entered, and I hit enter, you see this is reflected in the user interface, right? This is set as a value here, so that's great. But if we now inspect this again, we see there the value is still the default text we had in the attribute before. So there, this is not reflected back. Now, as I explained before, for CSS classes and IDs, for example, that's different. If I select my h1 tag here with getElement by ID main title, and I then set the ID equal to new ID, for example, I don't lose my reference here, by the way, because here we set up this connection, and thereafter this is mapped to the address in memory. So the address in memory is stored here. So if I change that ID, this doesn't clear that connection. Just the same command would of course not work again, because in Elements we now see this has a new ID, and this is now also reflected here in the HTML code. So there it is reflected back into the attribute. The same would be true for class name, by the way. Now, important, if you do want to change an attribute, then you also have a method for that. You have a set attribute method. So on the input, for example, we could call set attribute, and this takes two arguments, two parameters. And the first one is the name of the attribute. So here we could set value, should be a string. And the second is the value you want to assign to that attribute. So here's some other default text. And if you do that and you hit enter, this does not update the UI, because actually changing this value here will not overwrite any existing changes that might have been made, so that you don't accidentally get rid of the user input, but you do clear that value here. You do indeed change that attribute here. But since we have no live sync, indeed, if I go to the value that's stored in there, I still have that other value which was set, and not the new attribute value here. So value indeed, of course, is one of the more complex properties you can work with due to the way how it updates under which circumstances. But generally, of course, it's pretty straightforward regarding how this value attribute and property behaves. It behaves such that you don't accidentally clear user input, and that your changes you made to value aren't easily dismissed, but that you can still have that attribute around and either assign a new value, or of course, if you would want to reset the input, you could always just set value equal to input.getAttribute to get the value stored in the attribute, reach out to the value attribute, and since this doesn't reflect the current input, but instead whatever you set here or originally in the HTML code, you can run this code here to reset the content in there to that starting code. That's what I meant with that resetting and why this is kept around. So this is how you can work with attributes and properties, with set attribute and get attribute, and the dot notation to interact with properties like this. And this is therefore how we can evaluate values stored in DOM objects and also change them if we need to. Now let's dive into some other ways of selecting elements, which we haven't used too much thus far, or not at all to be precise, and that are the methods for selecting multiple elements. So let's say I want to select all list items, all LIs. Well, then we can do this with document query selector all, and then the li tag, for example. This will now select all elements on our entire document with a li tag. So all LIs, therefore, is such a node list now with 3 list elements, as you can tell. If you want to work with one of them now, you have to use all LIs and then access them by index. So index 0 for the first element, for example, second element, third element. This would work. Or, of course, you can also use a loop here. So here in app.js, if I want to get my list item elements, let's say, and store them in a constant name like this, then we can use query selector all and search for li, what I just did in the console. And now if you would want to do something with them, you can go through them with a for off loop for list item of list item elements. And therefore maybe here list item L to make it clear that we're working with elements here. And then here, for example, console dir list item L, like this. If you do that and you then reload, the script will run, and now you see that's getting output like that. An alternative to this, and this is the most modern way of doing that, but an alternative would be to use list item elements and select them by using get elements by tag name. And here you can also select them like this. You can access them with a for off loop. If we now reload, we get the same result. Minor difference, which I also already mentioned earlier, this gives you a live list which reflects changes to the selected elements. This does not. So I don't mean changes to the elements themselves. So if I change the text content of one of the list items due to that reference type thing which you learned about, that will be reflected in the objects we selected here. But the list itself, the number of items in the array, that will change here for this selected list if you add or remove elements, something we haven't learned about yet. It will not for query selector all, because that just takes a snapshot. The DOM objects themselves, due to being reference values, will reflect changes to them. That is important to know. So let's now summarize a bit what we learned thus far, what we played around with in the console. For example, we can select the h1 element with document get element by ID. Since this conveniently has an ID of main title, to get access to it like this. And then we can also use this to, for example, change its text content to some new title. This would work. We can also change its styles by accessing the style property in their color, white, and then maybe also the background color, like this, black. And here important, background color has to be written like this. With a dash, it would simply be invalid JavaScript. My IDE already complains here. And therefore, we have these mappings of the original CSS property names, which are pretty much the same, but dashes are removed, and instead characters after dashes are capitalized. So that would be one way of selecting elements. If we would want to select a list item, let's say the last one, we could use query selector for that conveniently, and you'll actually use that a lot because it is really nice to use. So last of type here with a pseudo selector, that would give us access to the last list item, so that on that list item we could also change the text content to maybe be the existing text content even, and add something new changed like this. Whoops, this here has to be li. And if I now save this and here we reload, now we see that changed title, and we see also that changed list item. And also nice to know, and something that's easy to forget, you can also get access to certain elements like the document body with document.body and store this here. And then we can actually also run our query methods except for get element by ID on these selected elements. Of course, not just true for body. That's just something I wanted to show you because we have a property for getting access to the body directly on document. The same is true for head. But actually, no matter how you selected it, if there is a special property available on document or not, or if you selected it simply with, well, get element by ID or query selector, on any element you selected, so on this body, but also on this h1 element and so on, you have the query selector and the get elements by something methods available to dive deeper into that part of the DOM, into that part of the DOM tree, if you will, and select child elements. So that's also something you can do. We had a look at how you can select elements in the DOM with query selector, with get element by ID, and so on. We also had a look how you can then use these elements to manipulate them or to simply read data from them. Now, there is another connected concept connected to selecting elements, which is typically known as traversing the DOM. And what does traversing the DOM mean? It means that once you selected one element, one node therefore, you might be interested in diving into all of its child nodes. For example, to edit all list items in a list or anything like that. So rather than manually selecting every element you might be interested in with query selector or so on, you could take an element which you already did select and then move to its children or its siblings and so on based on that element. That's what traversing the DOM means. Now for that, I first of all want to clarify a couple of terms which I'll use. Children, descendants, parent, and ancestors. Because it's important to understand what these things mean. So let's have a look at what child or children means, what descendant or descendants mean, what parent or parents mean, and what ancestor or ancestors mean. Now, when I say child, if I speak about a child element, when talking about these DOM traversal methods you'll learn about, then this always means a direct child node or an element, so an element node. And with that, I mean that here in this small example, the paragraph is a child of the div because it's a direct child element. It's directly below the div, one layer below it, so to say. The EM tag, the emphasize tag, however, isn't, because whilst the EM tag is still kind of nested inside of the div tag, it's not a direct child. The paragraph, the P tag, is in between. So the P tag is a child, the EM tag is not a child of the div in this case. Now, descendant, on the other hand, is a direct or indirect child node or element. So when we talk about a descendant, then in the same example, both the paragraph but also the EM tag would be descendants of div. So P, the paragraph tag, is a child and a descendant. The EM tag is not a child but a descendant of div in this example. Now, in parent and ancestor are kind of the opposite. A parent node or element is the direct parent node or element of another element. So in this example here still, the div is a parent of the paragraph but not of EM for the same reason as EM is not a child of the div. And the ancestor, on the other hand, if I talk about an ancestor element or node, then this is a direct or indirect parent relation. So there, for example, in that same example, we have div as an ancestor of both the paragraph and the EM tag. So that is important. That's an important differentiation. It will be important to keep in mind when talking about the DOM traversal and what you can do there. Now, as I said, DOM traversal means that you have a selected element, a selected node, let's say this div element node here, and now you want to dive into some of the surrounding or nested elements or nested nodes. And there you get a couple of directions into which you can go. You can always go up, so find a parent element or node with parent node or parent element, so with these specific properties which every DOM object will have, so every element object which you can select, no matter if it's a div or a paragraph or whatever, it will have this parent node and parent element property. The difference being that parent node selects, any parent node, whereas parent element only selects a parent node that also is an element, so only parent HTML elements. There also is the closest method which you can use to not just take a direct parent, but take any ancestor that matches a certain CSS query. And I'll show you how all of these work in action in the next lectures, of course. Now, of course, you can also go the opposite direction, and instead of reaching out to a parent or ancestor element, you can also reach out to a child or descendant element. There you have child nodes and children. Child nodes to select all, child nodes, including text nodes, children to only select child element nodes, so only HTML element objects. And of course, as I also showed you already, you can use query selector, get elements by class name and so on any selected element node as well. So these are also methods which are always available on any selected element object, and therefore you can always use these to dive deeper into all the descendants you might find there in that part of the DOM tree based on that element which you already selected. Now, there also are special properties you can use to get the first child, which selects the first child node, and first element child to select the first element child node of a given element. And the same is available for the last child node, and the last element child node, which you can select for a given element. So that's for going up in the DOM tree or going deeper into the DOM tree, so into nested elements. Now maybe you want to stay on the same level and want to select sibling elements. For that, you get the previous sibling and previous element sibling properties on any DOM object, which allows you to get the direct sibling of an element. And that of course works in both directions to get the sibling before or after the currently selected element. And previous sibling and next sibling give you the next sibling node. Previous element sibling and next element sibling give you the next element node that is a sibling of the selected node. So that's the theory. Let's have a look at it in practice. Here's the same example we already worked on, where we already do select things. And now here, let's start simple and let's select a list item here. Now, of course, you learned about different ways of selecting it, and I want to select this second list item actually. Now, for this second list item, there are a couple of ways which will not work. Since it's the second list item, not the first one, for example, you won't be able to select it with document query selector li, because that selects the first matching element, so the first list item in this case that is found, and that would be this list item, not this one. What would work is if you take the class, so .list item here, like this. Because since this is the first element with that class, it would work. But maybe you have a setup where this is not the case. Let's say, and let's actually change it as such, on this first list item you have the same class. Now all of a sudden, this way of selecting also won't work anymore as soon as we reload this page, because now this will select the first match. And now that we changed this, the first matching list item is, well, this list item here, now that I reloaded the page. So what can we do to select this item then? Well, we can use some DOM traversal techniques, which I already showed you. Of course, in reality, if you're building this page, you could also add an ID attribute or find other ways of making this uniquely selectable with the query methods you already learned. But it's important to also be available to traverse the DOM. So one way of accessing it would be to get access to the parent unordered list element here, to this element node, and then have a look at its child nodes or child elements, and then select the second child here, because that would be this list item. This can be done here in the console by getting access to the unordered list, for example, with document query selector ul, that gives us the first fitting element. So since we only have one unordered list in the document, it will give us access to this unordered list here. And now on this unordered list, of course we can use the query selector to select any elements nested in there, but we will have the same problem as before. If I search for list items, I get the first matching one, which is this, not this. The same if I use a class, so this won't really help us here. But what we can do is we can use some of the things I showed you on the slide. For example, you can output children here. If you look at ul children, this gives you a so-called HTML collection, which is an array-like object in the end. So it's not a real array, but it supports looping and so on. So what I already showed you. And there we know the second element is the one we want. So with ul children and then index 1 to get the second element, we would get access to exactly that list item I was talking about. And you see it's selected here on the left, right? If I type this here, even without hitting enter, it is already selected. So this would be one way. This also is a great place to understand the difference between child nodes and child element nodes, in case it's not fully clear yet. Here I'm using children, and this gives me access to all child element nodes. So only child nodes that are based on HTML tags, HTML elements. Text nodes are excluded here. Now please keep in mind that, as I mentioned earlier in this module, text nodes are also part of the DOM tree, of that tree that is created here by the browser to reflect your HTML document, and that there, even the white space which you add in your HTML file for readability reasons is treated as a text node, because it is text in your HTML file, right? So therefore, actually in our HTML code, here, of course, I also have a bunch of white space in front of the body, in front of the header, and of course also in front of the list item here. I also have a line break between the unordered list and the list item. So here the difference we can actually see is that children gives me this collection of element nodes that are direct children of this unordered list. So no other descendants and also no other types of nodes. If we use child nodes instead, now you see, instead of this HTML collection array-like object, we now have a node list array-like object. And if we output this, indeed, we see there's way more content in there. There are a bunch of text nodes, as you can now clearly tell, and of course also our element nodes, but also the text nodes, because child nodes selects all child nodes, whereas children only selects child element nodes. And child nodes therefore also includes text nodes. And here, this text, for example, in front of this first list item, that is exactly this white space which you in the end have here. So if we have a look at this text here, data here is actually its text content. We haven't learned about this yet, but where you have text content on element nodes to assign a text and automatically create a child text node for an element node, data on a text node sets the text of this text node. And here, this is the line break character, and then we have a bunch of white space thereafter, so a bunch of empty white space. And that's just what we have here. We have a line break after the unordered list, and then we have 1, 2, 3, 4, 5, 6 pieces of white space here, and that's exactly what we have here. We have the line break, and then we have 1, 2, 3, 4, 5, 6 pieces of white space here. So this is this text node. Now, why is this not rendered here? It's not this white space in front of the bullet point, in case you're wondering. Well, it's not rendered because we have no style that would render it. The default for HTML in most tags is, or the default for the browser for most tags, I should say, is that it basically omits empty white space that has no purpose. So white space like here between item and 1 is of course rendered, but white space at the beginning or at the end of the content of an element is typically omitted. You can change this with a special style though. If we expand this down there and you go to styles for the unordered list, which holds the elements we just had a look at, so which holds all these child nodes, there if we add white space pre, now you see it here on the left as well. You see there's a bunch of white space and the line breaks because this is some specific CSS styling which overrides the browser default of basically ignoring leading or excess white space, and it renders it instead. So now instead of ignoring all that extra white space, it is getting rendered, which is why the list item is still as big as before. But of course we can see there seems to be some extra content in front of it. And whilst we don't see it here in the Elements tab, or whilst this is not displayed here as a text node, we can see it here in the console. It's just this text node. If I hover over it, it's now selected. This is this extra white space that is getting rendered. A line break, and then also all the other extra pieces of white space we have in there. So that's children and child nodes, which allows us to select child nodes. Often you want to work with children because in most cases you're interested in getting access to the child element nodes. But if you need access to all nodes, you can use child nodes like this. And this, by the way, is then also how you can get access to text nodes. For example, with child nodes, and then by using the right index. Now, besides children and child nodes, we also have two other useful properties. Let's say you selected the unordered list with query selector UL, and there you want to get access to the first or to the last list item. Now, again, of course, you can always do query selector li last of type or first of type. That will work. But for one, this will cost a little bit of performance because query selector has to scan the entire page and then scan this quite complex CSS query and find the fitting elements. And it also just might be redundant if you already got access to the unordered list anyways. If you then know you want to work with the first list item, you can use first child to get the first child node, which in this case is a text node, or first element child to get the first element child node, which would be that first list item here. And of course, the same is true in the opposite direction. We also have last child for the last child node, which again is a text node here, or last element child, which for this unordered list is the last list item. So this might simply be quicker and cheaper to get access to than with a brand new query on the entire document. Of course, as a compromise, you could also go for query selector, li last of type. That's certainly better than scanning the entire document, but it might still be faster to simply use last element child if you know that you want the last, well, element child in the end. So that's children and child nodes. Now I'll reload this page to clear all of that. And now let's actually go in the opposite direction. Let's say we already selected a list item, let's say the first one, so that we can use a query method without any issues. And now we want to reach out to the unordered list, so to the parent. Now, needless to say, you can of course get access to the unordered list, for example with query selector UL, right? But it's about understanding how you can traverse the document so that in a scenario where you have a more complex document, you are able to easily reach out to the parent, for example. So here I get my list item now, and I don't select the unordered list, but instead the first matching list item here. Here we need an equal sign. Oh, and yeah, li is of course already defined here in our script, right? This already gets access to the last list item here actually. So I'll use a different constant name, li first document query selector li. Of course, we could have also worked with that last one. So now to get the parent, we can use li first parent element or parent node. Now this is not parents or parents nodes or parent nodes, simply because, well, each element, each node can only have one parent. That's how HTML works and how it's rendered. You can have multiple child elements or multiple child nodes. You can't have more than one parent element or parent node. So here, parent node gives us access to the nearest parent node, parent element to the nearest parent element node. And in this case, this is actually the same. And to be honest, in almost all cases, it's the same. Why? Because only element nodes can have child nodes. And therefore, of course, if you're on a child node, so to say, and you want to know about the parent, it's an element node. Text nodes can't have child nodes. You can't nest other content into text nodes, for example. They can only hold text, no other nested content. So you might wonder, why do we have parent node and parent element then? Well, there is only one exception to that rule, and that is document element. There, if you reach out to parent element, you see we get null. But if we repeat this and use parent node instead, we get the entire document object as a parent node. And I will be very honest, this might be nice to know. It is something which will probably never really matter in the code you write in your projects. Because if you want to get access to the document, you can just select it with the, well, document object. Traversing to it from some child node might just be a lot of work for something which is already available on this document object, right? So I don't really see a great use case for this. I just wanted to let you know why both exists. In reality, as I said, for all other elements, parent element and parent node always refers to the nearest parent element, and that always is guaranteed to be an element node, and therefore you can use either of the two depending on what you prefer. Now let's get back to the other example here. I have my li first element, and I reloaded the page, so I'll reselect it. And now let's say, from that first list item, I want to get access to the body here. Now, this is kind of a redundant example because we can always easily get access to the body with document.body, but I'm just picking this as an example since I have no other ancestor in between the unordered list and the body. And I want to show you that, of course, selecting the unordered list is easy with parent node or parent element, but if we want to reach out to another ancestor, and header, for example, wouldn't be an ancestor because it's not wrapped around the unordered list, So if we want to get access to another ancestor, parentNode and parentElement don't help us, because with those we only get access to the nearest direct parent, not to any other ancestor. To get access to another ancestor like body, which is an ancestor, we can use the closest method. And the closest method takes a CSS selector just like query selector. And here, for example, I can enter body, and if I hit enter, you see now the body element is selected. And just to prove that this wouldn't work with header, which isn't an ancestor, if we try that, we get null. So closest is a nice method for selecting any ancestor anywhere up in the element tree, as long as it indirectly wraps the unordered list in this case here, or this list item in the end, that's what matters here. And then, well, closest just takes a CSS selector to allow us to conveniently pick the nearest ancestor element. Now, if you want to pick the nearest descendant element, then of course that would be done with query selector and so on, right? That's for diving into nested elements of the selected element. So that's how we can go up and down the tree. Now, what if I actually want to select the header based on a selection of the unordered list, or even of the list item? Well, if that's the case, li is already my last list item here, because we have that here in our JavaScript code that we select this list item. And now when we want to reach out to the unordered list, that's of course easily doable by reaching out to li parentElement or parentNode, and I'll store the result in ul because that will be my unordered list here, as you can tell, right? So that's what I selected here with something you already knew, and I'm storing this reference to the STORM object, which I in the end get here in my ul constant. Of course, that's the same as if I would have done query selector ul in this example here. In other examples where you might have multiple unordered lists on the page, that might not be the same. You might be selecting a totally different unordered list. Here in this example, where we only have one, that would of course be the same. So we have the unordered list selected, and now I want to get access to the header here. Now the header is a sibling of the unordered list. It's on the same level as unordered list. It's not a parent or an ancestor, and it's also not a child or a descendant. It's on the same level. And for that we can use the previous sibling or element sibling properties, which are made available by the browser. Now, just as before with child nodes and so on, here previous sibling gives us the previous sibling node, and in this case that's actually a text node. So that's this text node, this line break and excess white space we have in front of every item in the end. Here, if we have a look at the HTML code, in front of the unordered list, we have this excess white space and this line break after header here. So that's the nearest node we're selecting here with previous sibling. Of course, if I want to reach out to the header, I'm not interested in the nearest node. I'm not interested in this text node, which is basically between the header and the unordered list. I want to get the nearest element node. And I can do that with ul, and let me clear that to make it easier to read, ul previous element sibling. This gives us the nearest previous sibling element node. Not any node, but the nearest element node, which of course in this example here is the header. And it also works in the other direction, of course. If I want to get the sibling after the unordered list, so the input here, well then of course I can use my unordered list here, and then we have next sibling to get the next sibling node. Again, that would be a text node, because if we have a look here in our code, maybe after unordered list we have a line break, then some space, so a couple of white spaces here, and then an input, and therefore we have this text node. So if I'm interested in the next sibling element node, then we would have to use next element sibling, and this gives us access to the input, which is the next element node in line here. So this is how that works and how you can work with these different DOM traversal techniques. This is always useful if you already selected some element in your document and you know the next operation I want to do should be done to the next sibling or to the first child or something like this. Using these traversal properties can simply be quicker than always starting a new query with query selector and so on. And it's also not just faster for you as a developer, where you don't have to find a selection criteria. It's also faster for the browser, because with query selector, if you use document query selector, it of course has to go over all elements in your document and find matching ones. That is still not super bad, but it's certainly worse for performance than if you say ul next element sibling. So if you have a possibility of reaching out to the element you want to select with this command, definitely do it, because this is then a quick and cheap way of getting access to that sibling element in this case. One important note about all these DOM traversal techniques here, by the way. It's super important to be aware of them. And as I mentioned, for example, if you want the first list item of an unordered list, and you have the unordered list selected anyways, it might be best to just use first element child to get access to the list item than to run a brand new query with query selector, both for performance reasons, but also to save some code. Here, it also makes sense because a list item is pretty guaranteed to always be a child of an unordered list, and therefore even if you later go to your HTML code and you change things around, it's to be expected that this relation between unordered list and list item will be the same. So if you have code where you select the first element child on an unordered list, it will probably always be a list item. That might not be true for your entire page. Let's say here in this example page, we write some JS code, and for that I'll clear that old code, which I don't really need here. And I select my unordered list by reaching out to document body, and then here, in document body, in the end, it's of course the sibling of this header, right? So I could reach out to first element child, which is the header, because in my body, this first element child is the header. And then based on that, so once I got the header selected, I could take the next sibling, because that will be the unordered list. So here on the first element child, which is the header, we could now call next element sibling. So that would work because this here, up to this point, this selects the header. So on the header object, we can of course call next element sibling to get access to the next element sibling, which is our unordered list. So now if I want to get the first li, I can of course say ul first element child. And if I console log first li here, and we save that, and we reload this page, go to the console and reload, we see that works. The problem with that is, for one, this is a bit hard to read. If I'm reading your code, it's not immediately obvious for me that you're selecting an unordered list here. Sure, I can tell by this constant name, but if you're picking a different name here, it gets hard. And this code might be simply difficult to understand because I have to look at the HTML code to see what you're doing there. So that's one downside. The bigger downside is that here, maybe as you work on this app, at some point of time you decide, oh, I need an extra section element here, a section tag, and you move your unordered list into this section. Now if you do that and you don't adjust your app.js file, which is easy to overlook, then you might get unexpected behaviors in your app, because now if we reload, we of course got the unordered list selected here and not the first list item anymore, because we didn't adjust this selection code, and we select the header and then its next element sibling, which now no longer is the unordered list, but which is this section. So if we then select the first element child of the sibling of the header, that's not the first list item anymore, but the unordered list, because the sibling of the header was the section, the first child is this unordered list. So using these DOM traversal properties can be very powerful, but you should do it with care. Use it in cases where it's likely that the relation you're traversing will stay the same. Even if you move code around, list items will always be in an unordered list. In cases where this can't be guaranteed, carefully check your JS code and adjust it if you adjusted the HTML code. And also, of course, don't be shy to use the query methods. They're not bad or anything like that. Just because this could yield a better performance does not mean that the other approach yields horrible performance. You'll not even feel the difference. Just try to be smart regarding what you use. And that is also something that will come with experience. There also is no strict wrong or right. It's important to know both. And in cases where the relation is always the same, DOM traversal properties like this one can be nice. For general selection things, like generally selecting an unordered list, using query selector might be better than trying to do that by traversing the DOM. But that's just a general hint or just a thought I wanted to put out there to make sure that you're able to write good code that doesn't suddenly and unexpectedly break. Now that we know how to select elements, both with the query methods, getElementById, but also with the DOM traversing techniques, and that we also learned how to evaluate and manipulate elements, let's have a look at one specific way of manipulating elements, and that is changing their style. I already showed you how that works with the style property, but turns out there are other ways of doing that as well. So of course you can use that style property with which we already worked. With that, you directly target the individual CSS styles applied to that element. It's like using inline styles on the element in your HTML document. So if you know a bit of CSS, you'll also know that this has the highest specificity, which means styles assigned on the style property will override any other styles that might be assigned to an element by a class or anything like that. Now, important here, as you learned already, the style property names are based on the CSS property names, but they are adjusted. For example, background color is written like this and not as it is in CSS with a dash. Now, that's one way of setting styles, but there are other ways. And it's kind of obvious if you think about it. You, of course, can also manipulate the CSS classes that are added to an element. So with the class name property, you can set the CSS classes that exist on an element to dynamically change these classes, remove them, or add new ones. And that, of course, means that you adjust the styles that are applied by these classes, because you control the classes on an element. With class name, you set and control all classes at once. Class name is a string, and it's a string of all the classes that are added, so you can manipulate that string to manipulate the classes. By the way, you of course alternatively could also change the ID or some other attributes of an element if you're using an ID selector or attribute selectors in your CSS code. But CSS classes are of course the most common way of spreading styles across multiple elements. Now when it comes to CSS classes, you actually also have another way of editing the classes on an element. Class name takes one string, which is simply a string of all the classes that should be added, and therefore if you want to toggle a class there, you have to manage it manually, that you keep classes which you don't want to remove and only remove the classes that you want to get rid of. To make that a bit easier, all these element nodes also have another property, the class list property, which is in the end a JavaScript object and not just a string like class name, but an object with a couple of built-in methods that make it easy for you to add, remove, or toggle CSS classes, so that it's easier for you to manage individual classes and not having to do the string micromanagement that you have to do with class name. It gives you fine-grained control over the classes that are added, and you can even use it in conjunction with class name, though you should be careful that you don't override each other, and typically you use either of the two. So let's now dive into all these options to make it super clear what's happening there. Back here on our page, as I left it, we have the section with the unordered list. And let's now say we want to style this section. Now, of course, for that, we can simply get access to it with document, query, selector, section, for example. You could also assign an ID to it and use getElementById, but I'll just use that. And now with the section available, we can of course add some styles. For example, with inline styles with the style property, we can add a background color, but of course you can add more than just the colors. I'm just working with these since you can quickly see the impact. So here we can set background color to green, for example. And this looks beautiful, doesn't it? So that's what you already know. You can reach out to the style here and set it like this. On the Elements tab, by the way, you see that this indeed added the style attribute and reflected your change back into HTML. Here, with the adjusted CSS styling even, which you could add yourself in HTML. So this is what JavaScript does for you behind the scenes. Now that's not too new, that's what we did before. Let's now go back to our code, into the HTML file, and play with a bunch of CSS styles. For this, I'll add a style block here in the HTML file. Of course, we could also import some CSS file, but I'm not writing that much CSS, so adding it here is fine. And I'll add a redBG class here. So I'm writing some CSS here, where the background color is set to red and the text color is set to white. I will also add a visible class here, where I set display to block, and an invisible class here where I set display to none. And these are all just some CSS properties which I'm setting here. So now we have 3 CSS classes to play around with. Now let's say on section here, I'll add class redBG. So this red background is always there. With that added here, if we save this and we reload, we have this red background on the section thanks to this class. Now, no JavaScript is involved in this step. This is just some regular CSS styling. Now here in the app.js file, I'll select this section here with document query selector section like this. And now, of course, we can change the background color here, for example, to blue, again, using some inline styles. And that's what I meant. Now, if we reload, this is blue, because whilst the class is still there, and theoretically the styles by that class still get applied, due to the way CSS works, inline styles have a higher priority and therefore override the class styles, the clashing class styles. But that's not the main thing I wanted to show you here. Instead, let's now actually go there and remove this red background class. And for this, we can reach out to class name, to this class name property on the element, and set this to an empty string. This will basically set this class attribute to exactly this string. So if we save that and we reload, the blue background is gone because, as you can tell here, nothing is assigned to the class attribute because we reset it to an empty string. Now that's convenient if you really just want to clear everything, or if you then maybe want to set it back upon some code change. Then you can also do that, and now it'll be there because we don't only set it in HTML, we also now set it again here in JavaScript. And please also note, redBG is added here in HTML and now also here in JavaScript. And it's not added twice or anything like that. Instead, class is really set equal to your string here. And now that can become a problem. Let's say we want to keep the red background, but we want to add another class. Now, right now, that means you have to set the string to the class you want to keep and your new class. Now, for that, let's add a button here, maybe here, and we say toggle visibility. And let's select this button here in app.js. So here, I'll select this button. Since it's the only button, we can again use query selector button here. And now on this button, we can do something we also saw before. We can call add event listener, add a click event, and then here an anonymous function. I'll use an arrow function. You can use whichever function type you want. And there, when we click it, I want to set class name equal to redBG visible, which is one of the other CSS classes I defined here, and invisible if we are in visible mode. So I want to swap this visible mode depending on which mode we're currently in. Now that's a bit complex to code here. Of course, we could add extra variable, which helps us manage the current visibility state. If we only want to do it with the selected section, I have to check if section class name is equal to redBG visible, and that only works because I know I will at most have these two classes, or I will exactly have these two classes eventually. If I had more classes that even change dynamically, that would be even harder to check here. But here I know if I have that, then I want to set the class name here to redBG invisible. Otherwise, in the else case, I want to set it to redBG visible, right? So now with that logic, which again only works that well in quotation marks because we don't have more classes than these. But even with that code, we already have quite a bit of code here. But now if I reload this, if I click the button here, you see this in the end, after clicking it twice, toggles the visibility here as it, as you can see on the right, dynamically changes the classes. Now the problem with that approach is that we manually have to keep track of the classes we add, which class is there, and so on. Now that can be done in an easier way. Instead of using this, you can use this class list object I was referring to. So class list is another property you have on every element node, and there you got a couple of nice methods. You got a contains method to quickly check if a class is set. So for example, here you could then easily check if the visible class is set, and don't worry about the entire string. You don't have to worry about other classes that might be set. You can simply check if that is set. You can also call add to add a new class or remove to remove a class, so that's all nice. You can replace a class, and you can also toggle a class. And here we can toggle the visible and the invisible class. Now I just have to go to index.html, and initially here I'll add visible as well. And now class list will automatically check whether visible is set when we call toggle visible, and will remove it if it is and add it otherwise, and the same for invisible. And the result of that is that if we now reload, this toggling works just as before, but with less work from our side. Now, of course, here actually adding visible is totally irrelevant because invisible is the one that does the main work here and that sets display to none, so we can actually even comment out this visible part and only add invisible. But I hope it becomes clear what the power of class list is. It makes managing CSS classes much easier, and that overall allows you to dynamically add or remove or change classes, CSS classes on an element, and therefore that in turn allows you to dynamically change styles. Because whilst you sometimes might want to change inline styles, more often than not, you want to add more complex styles to an element. And instead of setting them all as inline styles in your JavaScript code, which also is hard to find for other developers, you typically want to take your CSS code and dynamically add or remove classes. That also makes it easier to work in a team, where you might have one colleague working on the CSS styles and you working on the JavaScript. If you have to set styles in JavaScript with inline styles, then you have to know CSS and you have to align with your CSS colleague. If you use class list or class name, but better class list for more flexibility, then your CSS colleague can give you the CSS code and you can dynamically add or remove classes from that code based on your logic, which simply makes working on that easier as well. So now we have an understanding of how you select elements with different selection methods, most importantly getElementById and querySelector. We have an understanding of how you traverse the DOM based on an element which you selected with parentNode and so on. We have an understanding of how you can read values from a DOM element and how you can manipulate DOM nodes or DOM elements. Now let's have a look at how you can create and insert brand new elements, because that's something we haven't really covered thus far. Now for that we have basically two different ways of doing that. We can, and that might sound surprising, but we can write some HTML code in JavaScript and tell JavaScript and therefore the browser that it should take and parse this HTML code and render it in a certain place of our document tree in the end. Or we use the createElement method on the document object to create a brand new node and manually then insert it somewhere in our document. Now the HTML string can be added with the inner HTML property which you find on element nodes, and that indeed adds and renders an HTML string, so some HTML code in that place where you add it. Alternatively, you also have insert adjacent HTML, a method you can use if you want to add some rendered HTML content next to existing content instead of replacing that content with it. So that's also supported. Or as I said, you use createElement to create single DOM element nodes instead of a bunch of HTML at once. Such created elements or element nodes can be added with append child or append, and I'll come back to the difference throughout the next lectures. So this appends such a new DOM element or node inside of another of the new parent element or node then. You also have prepend, before, after, insert before, and so on to be more specific where you want to add it. Instead of adding it at the end of the existing child node list, you can add it in front of it and so on. So that can help you be more specific about the position where it should be added. And you can also replace an existing node with that with replace child or replace with. That's also possible and allows you to basically remove an existing element and replace it with a new one. So these are different ways of manipulating the document. Let's now have a look at them and understand their differences and when to use which. I want to start with inner HTML, and for that, let's select this section again, and let's say we want to entirely change its content. So for this, we can use this section element, which we already have selected here. So I do already select section here and store it in a constant in my app.js file. This is also available here in this console. As you can see, if I type section here, that's this section element. And there, as on every element node, you have an inner HTML property. You saw text content before, which in the end gives you access to all text in there. By the way, that might be interesting. You see, this is all the text of all the list items. So not just direct child text, but any nested text. And you can also set new text content here, like this, which by the way will also replace any existing HTML content in there if you now inspect this. So that's also interesting to see. Text content can also be used to set new content, but only text content. If you want to set new elements and so on, you use inner HTML, and now you can really set this equal to a string that contains HTML code, like for example, h2 tag, a new title. And important here is that this works, as you can tell. Now we have this h2 element in there, but it will always replace all the old HTML content. So any previous nodes between the section tags, and not just direct child nodes, but any descendants will be entirely replaced with this new HTML code. So that's what inner HTML does. It really just swaps the entire nested HTML structure, all nested nodes, with your new content. Sometimes that is exactly what you need and want, then this is great. But sometimes you just want to add a single new element and keep the old content, and then inner HTML is not that great. Now, one workaround you might come up with is that you append content to inner HTML. Let's say here we select the unordered list and store it in a list constant with query selector UL. And now I want to keep my existing list elements, so all existing free list elements, and just add a new one. Now you could do that by setting list inner HTML equal to, and now list.inner HTML plus, and now the new content, right? So now I add a string with a new list item here where I say item 4. This should in the end take the existing inner HTML content, which is that structure we already have here, and just add a new list item at the end that should be rendered. If we hit enter, this indeed works. The other three items are there and the new one was added. But this approach has a major downside. It becomes clear if we go to elements here and open my console here. Now here I'll just repeat that code here just with item 5. Now don't watch the console, also don't watch the part on the left. Instead, let's now watch this unordered list here in this tree structure here in the Elements tab as I hit enter. Did you see that? It all flashed. And this indicates, that's how the Chrome DevTools behave, that all the items that flashed indeed changed and were kind of re-rendered. So what happened here in the end is when we do that, we replace the entire HTML content of the unordered list with brand new content, which, yes, is based on the old one, but still everything gets re-rendered. This has two important implications. For one, it's not great for performance. You're forcing the browser to re-parse and re-render a lot of HTML, which didn't change at all. Now, of course, for a short list on a simple page like this one, it doesn't really matter. But if you're working with bigger websites, bigger applications, that might be super bad and really hurt the user experience. Now, in addition, if you would do this to some other element, let's say this input, and I can even show this, then you'll face a totally different problem. Because let's say here in our index.html file, that input would be inside of a div. So I added a simple div, the only div I have on this page, and I move my input in there. So of course, I can now get access to that div here if I reload by using document query selector div. And then let's say for some reason I want to change its content. So I reach out to inner HTML and I set this equal to div.innerHTML plus, let's say, a paragraph, which I want to add below it. Something went wrong because the user entered something incorrect into the input, let's say, and you want to tell the user, right? So we're rendering this paragraph and we're keeping all the original content. We don't change this. Now let's say I entered something here into the input. So I changed the text and now I execute this command. Now what you'll see is that my input is lost. And the reason for that is that, as I just explained, all the content which you swap with inner HTML is re-rendered, even if it's based on old content. A brand new element is rendered here, and therefore the user input is lost. So that's the other downside of using that. So inner HTML is useful whenever you want to change everything, all the HTML content of an element. It's not so good if you only want to add something to the existing content. That's one thing to keep in mind. Therefore, a better way of updating this to keep the user input here, which I just typed, would be to use div insert adjacent HTML. This allows you to target a position and then define which HTML you want to enter. For that, as so often, it's good to Google for JS, insert adjacent HTML, and find the respective MDN article. And there you find the different values for position where this should be inserted. Before the element, just inside before the first child, at the end of the element, just after the last child, or after the element itself. And here you also see a visual representation of where stuff is entered. So we basically have 4 values: before begin, before end, and after end. And hence here, we could say before end, so inside of the element, inside of the div, but after its last child, so after the input in this case, I want to enter this paragraph. Something went wrong. So now the same HTML code as before, but inserted with insert adjacent HTML. The result is if I now hit enter, this is kept and not reset. Instead, we just added this new paragraph, in this case after the last paragraph, which I entered with this code here. And now this does not re-render everything, but really just insert this code and render this new code, since you explicitly tell JavaScript and the browser that this should be added next to the existing content. So this is one way of adding new content to an existing element with some HTML code which you write in JavaScript. And this is therefore a great way of manipulating this. Still, whilst this might seem perfect, there are scenarios where you don't want to do it like this. Do you have an idea when using HTML code like this, or even with the better adjacent HTML method, might not be great? Performance is not an issue here with this adjacent HTML method, and also not that we would lose user input, so that's not the reason. Well, a downside of this approach is that you tell the browser which element to render, or which content to render, and that can be any HTML content, doesn't have to be a single element, can be any as complex as you want HTML code. The downside just is you have no direct access to the newly rendered content. Let's say you would want to later reach out to this paragraph and change it, or you inserted a button and you want to add an event listener. Well, then you have to do good old div query selector and query for a paragraph, for example. In this case, we of course fetch the first one because we have 2, but you get the point. This would allow us to get access to this paragraph. Now, the more complex the HTML code is you inserted here, the more complex is to query for the right things so that you get the objects with which you can work, where you can add event listeners, where you can change the properties and so on. So the missing direct access to the inserted elements can be a problem. Of course, it's not if you don't plan on doing anything with the inserted elements in your JavaScript code. But as soon as you need to add event listeners, or change styles, or read some values, or do anything else with them in JavaScript, this approach has the downside of not giving you direct access. And if you find yourself inserting content like this and then querying for it thereafter, you're basically running 2 steps to get access to a newly added element, when there actually is only 1 step required. And that's the case with createElement, with this other approach of adding new elements. So here I reloaded this page on which we worked all the time. And now let's say here in the unordered list, I want to add a list item at the end on which we can click. Now for that, just as before, we can get access to the list with document, query, selector, ul, like this. And now, of course, we could use inner HTML or insert adjacent HTML, but now I'll do something else. I now want to create a new element node here in JavaScript and then append it at the end of the list. And this can be done with document.createElement. Now, you always call createElement on the document. You don't call this on any other DOM node or DOM object. It's always document.createElement. This creates a new element, a new DOM object, just like you could select it, but it creates it from scratch. And it takes at least one argument here. And that's the tag name you want to create. So the tag name of the element you want to create. In this case, li, because we want to create a list item. Without the brackets, so without the angle brackets, just the tag name, which you find between the angle brackets. So li here to create a list item element. In case you're wondering about the second argument here, we don't need that here. This is actually an object with exactly one property that is supported, the is property, and that is related to custom elements, a very advanced topic which we'll not cover here. This is the form in which you use this pretty much all the time. So here we create a list item, and I could hit enter, but then we create it and we just let it go into the void, and it will actually get garbage collected because I'm not saving it anywhere. It creates a new element and it actually returns it. So now we can store it in a constant maybe, which is maybe named new li. Of course, the name is up to you. And this curly brace has to go, of course. So now we have the new li available. If I output it here, here it is. But of course, if I hover over that, that's not getting highlighted on the left here because it hasn't been inserted anywhere. But now we can do that. Now we can reach out to our list, which we got access to earlier, and we can insert li here with append child, for example. This takes any node. Actually, you could also pass a text node here, but you typically don't create text nodes in JavaScript. You just set text with text content because you rarely want to add a text node next to existing element nodes. So therefore, this is not really a use case. So instead here, you use append child and pass in this new li. And if you do that, you'll see this bullet point here, and of course no content next to it. But since we have access to new li, we can now also set text content equal to item 4, for example, and you'll see it appear here on the left. Typically, of course, you would first finish up configuring this and set the text content and anything else, and then append it, instead of first appending it and then completing it. Because you only want to append it once you're done configuring it. And you can set the text content and the style prop and so on, even if you haven't added the item to the DOM yet. Because it's already there in JavaScript memory, you can work with it. So this is now how we can add it. And the big advantage is now that we already have this object now where we can add event listeners or change the style or do whatever you want. That is all possible now thanks to this way of adding it. So we saw document createElement, which is really useful for creating DOM objects with which we then can interact. And we did insert it with append child. Nothing wrong with that, but there also is append. The difference is not only that append is shorter, but that append also does not only take our new li, which we created, but that here you can also add a string, some text, for example, which is then inserted as a text node next to the other element nodes. So if you want to insert a text node, you can conveniently do it like this. Another difference, by the way, is that you can add multiple nodes here, simply separated by commas as multiple arguments to append to add multiple nodes at once in that place. That's also a difference to append child. Now it is worth mentioning that if you Google for JS append to find the MDN entry on that if you scroll down to the browser support table there, that Internet Explorer, no version of it, supports append. Edge does, and Safari and all other browsers, but if you need to support old versions of Internet Explorer, you might prefer append child. But that really depends on the user base you're targeting. If that's not an issue for you, then you can absolutely use append instead of append child. Otherwise, append child has been there for longer and is simply safer to be used. In the browser support module later down the course, you'll also learn how to make features like this work in older browsers like Internet Explorer, which would normally not support it. So that was append and append child. We also got more. So again, let me get access here to our unordered list. And let's create a new LI, a new list item, however you want to call it, with document createElement as you learned. LI is the tag name. And now there we can add a text content of item 4, since I reloaded this page. The old one which I added is gone. And now we can of course append new LI as you learned. But let's say we want to insert it as the first element. Well, then we can use prepend. So we can call prepend new LI, hit enter, and now item 4 is actually the first element. Now, just as before, searching for JS or MDN prepend is helpful to get the official article and scroll down to the browser support table to learn that here again, Internet Explorer does not support this. So with the same thing as with append, this is not necessarily supported. Still, to show you a couple of other methods and one other interesting behavior, let's say we decide we actually want to use it somewhere else. We want to add it before the currently last list item. Now we can get access to that with list and then last element child, right? That gives us access to the last list item in the list. And now I want to add the new list item, item 4, which I already did add, but I want to add it again, let's say, in front of item 3. Now for that, I can now call before here, and I can pass in new LI here, or as many nodes as I want to insert before this selected last element child, so item 3 in this case. If I hit enter, item 4 is added there, but the interesting thing we see here is that item 4 is now actually removed from the beginning of the list and basically moved into this place. If you have an element selected, either because you selected it in the DOM with query selector or because you created it with createElement, and that element is already part of the DOM, so it is already rendered, if you then insert it somewhere else, this is not copied or anything like that. Instead, the existing element is detached from the place where it was and moved to the new place. And I guess this actually makes a lot of sense since objects are reference values as you learned, and the DOM objects you're working here are nothing but normal objects in the end. And therefore, if we do something with it and we add it somewhere else, we always work with the same object. So of course, it's detached from the existing place and moved to the new one. It's just something to be aware of. If you want a brand new one, you have to create a brand new one with document createElement. Now, and of course, you don't just have before, you also have after to insert it after this selected element, unsurprisingly. And you also have replace with. So if I select, let's say in this case, the first element child, and then I use replace with and replace this with new LI, then you see item 1 is now dropped actually because replace does not swap it. It just, well, replaces the element with it, which means it gets rid of the old one and replaces it with a new one. And therefore the old item 1 is replaced with item 4. So these are the different ways of inserting this in different places. Important, append, before, after, and so on. They all take multiple nodes if you want. So you can absolutely say append, new LI, and some other item which you might have created. They also take strings, so text nodes if you want to, but most of the time you'll use them with single elements, and then they simply give you a lot of flexibility and control over where this element should be inserted. Just keep in mind that inserting the same element multiple times will move it because we're working with objects here and not with some automatically copied things. Now, one word about before and after. If you search for it on MDN and you again check the browser support table, you'll see that here we actually also have a problem with Safari. So whereas append and prepend work on Safari and only don't work on Internet Explorer, before and after also have problems on Safari. So there you want to be even more careful for whether you want to use that or not, and maybe find different ways of inserting elements than with before and after. Now, what would be such a different way of inserting an element in a specific position if you want to insert an element, let's say, after item 2, which you can't really do with append child or so on? or anything like that? Well, for that, you might want to select the element you're interested in. In this case, my second list item that could be found on children and then index 1, right? That gives me the second item. So second li is now stored in there. And now if I create a new list item, and I reloaded this page so that I can create it all again from scratch, and I create a new list item here, and I set new li text content to item 4, and I want to insert this after this second li, well then, of course, the most convenient way would be to use second li after, but again, support for that on Safari is not that great. So if you want to avoid it, then you have another useful method, list.insert adjacent element. If we have a look at this on MDN, then we see, just like insert adjacent HTML, these are the strings we can use. And browser support is way better. So now here we could insert this inside of the list, or since we want to insert it next to the second li, we can just go to that and call insert adjacent element, where is after end, if we want to insert it after this one, because as you can see here in MDN, after end inserts element after the element you selected, so after the second li, and then here it's the new li which we want to insert. And now item 4 is inserted after that second element. So insert adjacent element, whilst being a bit longer than after and before, is the safer way of doing this, of inserting elements after or before other elements, since it has better browser support. So that's also something you should be aware of. So you learned that inserting an element more than once will move it and not copy it. If you would want to copy an element, well, then you can do this with another method which is available on every DOM node object. So let's say on our new li with clone node. This will clone this node and will really return a brand new one. It takes one optional argument, and that's a boolean which can be true or false, which by default is false, which simply determines whether a deep clone, so with all child and descendant elements, should be done or not. If you pass false here, which is the default, then only the list item itself is cloned, but no nested elements you might have in there. If you pass true here, then not only the direct child element, but also all child elements of that element, and all descendants in general will be part of the clone. So now if we do that, and we have new li2 where I store this clone, now I can of course go ahead to my list and let's say append new li and new li2, and the result of that is of course that item 4 is moved to the end because I appended new li, which already was part, but I also appended the brand new li2, which is why I have another item 4 here added to the end. So this is how you can also copy elements if you need to, instead of recreating and reconfiguring it. This might simply save you some time if you want to take most of the settings of an existing element or all of the settings and then just insert this brand new element into your DOM as well. So now that we have a feeling for how we can insert content into the DOM, let me come back to the live node list versus non-live node list thing. So we have this list here. We worked with it many times. I reloaded this document, so let me again select this like this, as we did it many times in this module already. And now here, I used query selector. This gives me access to this unordered list. Now I also want to get access to the list items in there, and for that we can use document query selector all li, and this will select all list item elements on this entire page. So of course not just in this list, but on the entire page. If we would want to restrict it to this list only, I would have to run this on the list instead of the entire document, which of course also works for this example here. So now I got my list items here, and if I output them, you see it's a node list with a couple of, well, list item objects in there, unsurprisingly. Now I will also fetch my list items in another way, list items 2 here, by reaching out to list, and then here I can use get elements by tag name, for example, and pass in this li tag name here. That's one of the older query methods which is built in. And if I do this, list items 2 is a HTML collection actually, as you can see. So it's still an array-like object, as I mentioned, supports a couple of the important array methods, but as you will learn later in the course in the array module, not everything you can do on arrays, but most of the things. And it looks quite similar. Well, let's now add a new element. So I'll add a new li here with document createElement like this and create a list item element. And so that we can see it really good, I'll also add a text content of item 4 again. Now, it's up to you how you want to insert this. You learned about different ways of doing that. Here, I'll just reach out to the list and use append and append my new li. You could use append child or target a specific place with after and before or insert adjacent element and so on. Here, I'll just insert it like this. And once we did this, we of course see it here on the screen. Now to the interesting part. We got our two list items constants, list items and list items 2. And on list items, you can already see this still is a node list with 3 items. So our most recent addition is not reflected here. That's what I mean with non-live array or non-live list. This is taking a snapshot of the DOM of what we select there when I run query selector all and does not update that array when that part which we queried in the past changes. Now, that's not necessarily a disadvantage from a performance perspective, from a memory consumption perspective. This might even be better. And I also want to highlight that, of course, the individual objects in there are still reference values. So an object in there is still, of course, a live reference to the DOM objects that are responsible for what we see on the page. So if I go to, let's say, the first item there, and I change the text content to item 1.1 here, for example, that gets reflected on the screen. Because the items are reference values, these are pointers at the objects, at the DOM objects in memory. Just the overall array is just a snapshot of list items when I ran that query selector all command. Now, if we have a look at list items 2, however, which is this HTML collection I got with get elements by tag name, we can see this indeed is a live list, which also includes our most recent addition. So all these get elements by something, not get element by ID, because that only gets a single element, which always is a live connection, so to say, but get elements by something. This always gives you array-like objects with live lists, which will change when the items you queried in the past change, so when the number of these items changes, I should say. That can or cannot be an advantage. Often it will not matter, to be honest. It could lead to a higher memory consumption if you're managing a lot of such collections which change all the time. But again, that will also probably only matter in rare niche cases. But for the most part, query selector all simply should be used because it is more flexible, supports richer queries, and therefore, well, often is a common choice if you want to query for multiple items. I just wanted to highlight this difference again, which sometimes can be an advantage, sometimes can be a disadvantage. Well, and often, to be honest, it will probably not matter that much. Now, being able to add elements is of course nice. Sometimes you also want to remove them. Now, with replace with, we are able to remove them, but of course only to replace an element with a brand new one. To just get rid of it, we of course also have ways. Now for that, I reloaded this document, and here, let's say, we want to get rid of that entire list. So I'll again select it with document query selector ul, ul as a string. And now to get rid of it, there are 2 ways. One is to use list.remove, and this will just do what it sounds like. It removes the list from the DOM, so from the rendered page. Now, good old MDN, if we check the remove method there, shows us, however, that Internet Explorer, again, is not too fond of this method. So if you want to ensure that this works there as well, you can't really use remove there. All our browsers have great support, so you can definitely use it there. But if you need to support this like this in Internet Explorer, then another way of making this work is to select the item you want to delete, and then You reach out to the parent element, so the element node above the item you want to delete, and there you have a remove child method. And to that you pass the item which you want to delete, list in this case, and it will also work. Remove child is supported in all browsers, just like append child, and therefore this is the safest way of removing an element, reaching out to its parent and then remove child and then passing the item you want to remove. But again, remove also has pretty good support. If Internet Explorer support doesn't matter for you, then just remove on the item you want to remove, just like this is of course the shorter and the recommended way. So we learned about a lot of different insertion and removal methods. Let me now summarize the important ones which we used here. Now, I'll not dive into the inner HTML and insert adjacent HTML methods, which I also showed you, but focus on the ones where we created a new DOM object programmatically in JavaScript. We can then add such an object with append child, with insert adjacent element, replace child, or remove child. Now, I haven't shown you replace child. In the end, this also just is a convenient method for replacing one element with another one. Now, attached you also find a detailed summary document, which you can have a look at to find an overview over all the methods you have available and when to use which. I strongly also recommend having a look at that. We also had a look at some of the more modern methods: append, prepend, before, after, replace with, and remove. Now, the main difference here is really browser support. Also, a minor thing might be that you find more examples on the internet using these older methods, which have been around for longer, than for these newer methods. Because these have also a good browser support, as you saw, but some browsers are not supporting all methods. For example, Safari doesn't support before and after, supports the other methods, but Internet Explorer is a big problem there. So this might be an issue if you need to support these browsers, and you will also see them a bit less often used in some of the other tutorials you find on the web. Which is why I find it important to learn all of them. If you want to be super safe regarding support and so on, you want to use the left ones, but the right ones also are pretty good, mostly if Internet Explorer users are not that important for you. And as I already mentioned, later down in the course, you will also learn how you can actually ensure proper browser support, even if you are using features that are not supported in all browsers out of the box. So you will even learn about ways of making these methods run in older browsers as well, later down in the course, in the browser support course module. Now again, check out the attached document as well. There you find a full list of all the methods you have available for that, what they do and when to use which. And with that, that should be all super clear. Now still, that was a lot of theoretical knowledge now. Now it's also time to apply at least some of these methods and features in a simple project so that we can see how we would use that in a more realistic app. So now that we had a thorough look at all the core building blocks or all the basics that you need to know in order to work with the DOM, work with this HTML page from inside your JavaScript code, I also want to apply some of these things in a more realistic project. Because thus far in this module, we always played around in the console, which is great to quickly get a feeling for what you can select in which way and how you can work with things. But now let's take the things we learned and put them into the context of a more realistic project. And for this, attached you find some starting files, index.html file and the assets folder. That's what you get when you extract the attached file. Got some basic styles in there. Got an empty app.js file because now there is no vendor.js file. Now we'll write all the JavaScript logic also for communicating with the web page on our own. And then we got this index.html file here with a basic HTML skeleton that in the end leads to this page. And here we're going to build a very simple application where we can click Add Movie. Currently nothing happens there. We'll of course change that. And when we click this, a modal, so an overlay, should open up where we can enter the title of our favorite movie, add an image, and also give it a rating. And then we'll display a list of the movies here instead of this box which we currently see. And we'll also be able to click on these items, so click on the movies, and then remove them if we want to get rid of them after we added them. So a lot of interaction going on. We'll also dynamically create and remove elements. We'll have to connect to a lot of elements on the page, so there will be plenty of opportunities to apply what we learned. So with that, let's not lose any time and dive right into it. Just one more word. If you feel like it, of course, you can always pause in this or in the next lectures and try out some of the next steps on your own, or when I start with a certain step, pause and try that step on your own. It's not a must do, but it might be a nice practice. So here's our skeleton, our HTML page. And right now, of course, no interaction is possible. Now, the first thing that would be great if it worked would be that if I click Add Movie, we actually display and overlay a so-called modal here, which is like a pop-up, but not this alert, which is controlled by the browser, but a pop-up which we create visually in our web page, which allows us to enter some movie data. And in the HTML code, we actually already got everything for that. This div here, this one here, this in the end is such a modal, has some CSS classes to look nice, has an ID, add modal, which might come in handy for selecting it later. And there I also already added a couple of inputs which allow us to add a movie title, an image URL, and a rating, which we then enter here, and then some buttons to either cancel adding that movie, which I also want to support, or for completing adding that movie, which should then add it both to a JavaScript array, but of course also output it on the page. If we scroll down there, I have an unordered list with no entries at the moment. I want to populate that list once we add movies. So the goal is to show this div. And of course, therefore, an important question is, why is it not showing at the moment? Well, actually, because if we have a look at the CSS code, in there I added a style to this modal class, which is the class I'm applying here to this div, which sets display to none, which basically means it's not added to the document flow. It's not visible, it's not clickable, it's like it wasn't there. It's actually part of the DOM. As you can tell, if you go to the Elements tab, there you find that modal, but you don't see it anywhere on the screen. If I hover over it here, if I select it, it's also not selected on the left because it's, well, set to display none. It's not part of the document flow, just of the DOM. That's an important difference because that means we will be able to select it from JavaScript and then we can toggle this display style to show it. Actually, there even is an easier way. There is this visible class which we can add to a modal, which will set display to block and also play a nice little animation to fade it in and to slide it in. So actually our goal will be to make sure that when we click the Add Movie button, we reach out to this div here with the ID add modal, and we then add this visible class. These are all things we of course learned, so here already is a great place to pause and try this on your own. But of course, after this short pause, which I give you to pause the video, we'll do it together. So let's try it together. And we got two steps with which we should start. We need to get access to this add modal div, and we can do this with the ID. We could also try to do it with a class selector, though you should be careful because we also got another modal here, another div with the exact same classes. So since this is the first div with these classes, we would be able to use query selector to select by class because query selector selects the first matching element. But later when we need to access the second modal, for example, we'll definitely need to use the ID or come up with some other unique selection criterion. So here I will actually go for the ID and select it by that. And you also must not forget that we also need to get access to this button so that we can add an event listener. And for this, if we scroll down, we can have a look. Here's the header and there is this add movie button. So we also probably want to select this. Now we'll have to see how we can select it because this button has no ID or anything like that. Now, of course, we can always add an ID and that might be a good idea. Give this some unique ID, which we haven't used anywhere else on the page. But also to practice the different ways of selecting stuff, I will also use a different approach of selecting this button. Now let's start with the modal though, and let's go to app.js, and in there, I'll add a constant because I'll never assign a new value, and I'll give it a name of add movie modal. The name, of course, is fully up to you, but it should describe what you store in this constant. And here, I'm in the end storing a reference to, well, my modal, so to this overlay which we can add. And it is the modal for adding a movie, so I will name it add movie modal. Seems like a fitting name to me. Now we can select it with document, and now we can use getElement by ID because our modal here has an ID, add modal. So that is probably the most reasonable way of selecting it. As an alternative to that, just to also show this, we could also use query selector, and then we just have to add a hash here because a query selector wants a CSS selector here. This would work as well, would also select it. This tends to have a bit better performance, though for this app it really won't matter. For most apps you'll probably not feel it, but it's a little bit better to use getElement by ID than to use a query selector if you really just want to get access to an element by ID. So that's just a side note. And another way of getting access, of course, also would have been to use other techniques. For example, we could dive into the body and then have a look at all its children, so all the child element nodes, and then pick the second child, because the first child is this strange backdrop thing, which will become important later. Second child would be that. So another way of selecting this would have been to use document body, and then there children, and then there the element at index 1, which is the second element. All these approaches select this movie modal. Just to prove it, I'll quickly output it here, comment out the first two steps so that we don't get errors because I'm using the same constant over and over again. And now with that, just go to the console here, reload. Now we see that selected this modal, and that's also true if I uncomment this and comment this back in, and then reload, get the same modal here. And also for completeness sake, and this is the approach which I will use, if we use getElement by ID, we also log that modal here. So these are just some ideas. Of course, there are more ways of selecting it, just to give you an idea for that. But I will go with this approach because if you have an ID, you typically should strongly consider using that ID at least. This also will be very fast from performance perspective, so there's little that speaks against using this. So with that, we selected the movie modal. Now, as I said, we also need to get access to this button here, to the add movie button. And for that, I'll add another constant here, add movie button, or actually I'll name it start add movie button. I'll name it start add movie button because later I will also have a button inside of that add movie modal. So instead of that modal which we just selected, there we also have an add button, and I want to give this the add movie button name later because this will be the button when we press it that really adds a movie to our app. The button in the header starts this whole addition process, which is why I will call it start add movie button. Now, how can we select that? Of course, there are different ways of selecting it. We could, for example, say document, query selector, and then reach out into the header and then to the button. So here I'm using tag selectors because I only have one header on this entire page. It's this header here. And then this is a normal CSS selector. We select a button inside of a header element. So we only have one header element. We select the first matching button, which in this case also is the only button in this header, and therefore this would give us access. So that's one way of doing it. Another way, of course, and I will not always show all alternatives, no worries, but here I do want to show it. So another way would be to use query selector header, and then, for example, last element child, because if we have a look at our header, here we see the button is the last element child inside of the header. So that would be another way of selecting it. The downside of using this, just as before with using document body children1 for the movie modal, is that whenever we change something in the structure, whenever we add something in the header, some other content here after the button, some other title or anything like that, then this way of selecting it here will not work anymore because it always selects the last element child. And if we change that in the HTML code, our JavaScript code will select the wrong element. So therefore, you should be careful with using this selection technique in places where the HTML content might change, where you as a developer might change it later. So therefore, I actually prefer this approach. As I mentioned earlier, an alternative would have been to add an ID to this button, but also to mix things up, let's use this query selector. So that was a lot of talking about selecting elements, but of course it is an important part of working with the DOM, and I want to be sure that you really know how that works and which options you have there. Now with that all selected though, let's add an event listener to the Start Add Movie button, because that's what we all came here for. We want to make sure that we can open that Add Movie modal, and that should happen when we click that button. So here we can use good old Add Event Listener, which we didn't have a closer look at in this module, but we already saw this earlier in the course, and I will have a closer look at events and how you can handle them in a separate module, because there's a lot you can say about events, and it's just not the focus of this module. Adding an event listener like this is something we saw before though, so we can easily add a click event listener like that with this line here. And now we want to add a function. We could use an anonymous function here, but I will actually create a standalone function here simply for readability, so that this is clearly readable and easy to see, so that our code is also very understandable. For that, you can define a function in whichever way you want, with the function keyword and the declaration approach, with the expression approach where you store the function a constant, or with the expression approach where you use an arrow function. That's the approach I will use here, but you don't have to follow that. You can use either of the three ways of creating a function you learned. So here I will name this toggle movie modal, because that's what I want to do. When this function gets called, I want to open the modal if it is open, and I want to close it if it is not open. Alternatively, of course, we add separate functions for opening and closing, but I think we can combine this quite nicely here in this app, so let's do it like this. Then, as I mentioned here, I add my arrow function. Alternative would be to use a regular function here, or even a function declaration, as I mentioned. Let me move that up here. And now inside of that function, we can use the add movie modal constant, so this one, which points at this div, which has that add modal ID, and there, in the index.html file, there on this add movie modal, we're selecting this div, right? So there we have that modal class, and in app.css we see that if we add a visible class to the same element where we have the modal class, we'll actually set display to block. So we need to add or remove this visible class to show or hide the modal. So here in toggle movie modal, we can do that in two different ways. We can set the class name property here, but then we manually have to keep track of which classes we have, and we have to make sure we don't accidentally drop a class which should always be present, like modal and card. Modal and card. These classes should always be there, so we have to make sure we don't accidentally remove them by setting class name here to something else, which is not supported by CSS or which misses crucial classes. And therefore, the better approach actually is to use the class list object, which you learned about, and there the toggle method, because this does exactly what we want. It checks whether a class is already on the element, and if it is, it removes it, and otherwise it adds it. And we want to toggle the visible class. So this will always keep all other classes on the element, but add or remove this class based on its current state. So based on the question whether this class already is part of the element or not. So this will actually, hopefully, show our modal. We just have to connect it to the click listener by pointing at toggle movie modal without parentheses here, of course, because we don't want to execute it immediately. We just want to point at this function. And with that, if we now save this and we reload this page and we click this button, indeed this modal opens up. Now currently we got no real way of closing it other than clicking this button again. Clicking cancel, for example, won't close it. Clicking anywhere else won't close it. And I would also argue it's a bit hard to see. It would be nice if the background would darken, if we had some black or grayish overlay over the background, also so that we can't click anything else whilst we are interacting with that overlay. So that will be the next task. It will be to select this backdrop, because that will be exactly what we need here. If we check the CSS code, there, if we search for backdrop, you see this in the end is this styling here, which sets the background to a transparent blackish color and positions this as a fixed overlay behind the modal. So our goal will be to also toggle the visible class on the backdrop when we show the modal. We could therefore do it in this toggle movie modal function, but actually I want to create a new function because we will need to reuse this backdrop also in another place of this application later. So I don't want to tie it to this function. Now, this again is a great challenge for you. Try it on your own first. And in the next lecture, we'll implement this together. So to implement this, we first of all need to get access to this backdrop, right? Now, it has an ID of backdrop, so it should be fairly easy to select, of course. We can add a constant here, maybe name it backdrop. And just one other note about the naming, you can always, of course, also name these things something L or element to make it clear that you're pointing at an element in the DOM here. I will really leave that up to you. There is no best or common practice regarding that. You will find different styles. You just should find and pick your style and then be consistent and not switch it too often, at least not in one and the same project. And here, to keep names shorter, I'll go with these names here, but as I mentioned, if you preferred it, you could add L or element here to make it really clear that these constants hold pointers at elements on the DOM or in the DOM. So you could name this backdrop element, but since I don't use the element annotation on the other elements, I'll just name it backdrop here as well. And with that, I want to select it, and well, since it has an ID of backdrop, of course, we can just say document get element by ID backdrop. That's probably the best way of selecting it, to be honest. An alternative, since it is the first element in our body, and this also is unlikely to change, to be honest, because it is such a crucial background, not always visible element, which we probably won't add much above it. We could, of course, alternatively also select it by saying backdrop is equal to document body first child, a first element child, because the first element child in our body, of course, is that backdrop. So that would also work, and it's also unlikely to change. So the HTML structure is unlikely to change regarding this relation of this div to the body. Therefore, this might actually also be valid, but I'll go for the ID, which won't break for sure, unless we change the ID on the element, of course. So with that, we got access to the backdrop, and now, as I mentioned, we could use it here and use class list, toggle visible here as well, but I don't want to tie it to this function because later I will also need the backdrop in other places. So instead, I'll add a new function here, toggle backdrop. Again, I will use an arrow function here also to be consistent. You could create this in any way. And I will move that backdrop visible class toggling code into that toggle backdrop function and then just call that function from inside toggle movie modal. And this allows us to then later also call that function from inside other places so that we haven't strictly tied this backdrop visibility to toggle movie modal. Well, and with that, if we save that and we go back, reload, click add movie, now we have that background. Now it would be nice if we also could click this background or this cancel button to then dismiss the modal and the background. Because right now, since this backdrop actually even overlays the add movie button, we get absolutely no way of dismissing this. And the expected behavior of an application like that would be that, well, of course the cancel button closes this, but also that clicking on the backdrop closes this. Now, as so often, great practice for you, but of course we'll also do it together. So let's make sure we can click the backdrop and we can click this cancel button to basically call toggle movie modal and toggle backdrop again. Well, toggle backdrop will automatically be called when we call toggle movie modal, because inside of toggle movie modal we call toggle backdrop. That's a lot of toggling, I guess. So how do we get access to the backdrop and to the button? Well, we actually already have access to the backdrop. All we need to do there is we need to add a new listener to it so that we can react to clicks on the backdrop. So here we can add an event listener, a click listener. And now here important, I don't always want to call toggle movie modal, so I don't want to tie this to the backdrop, because whilst here in the current app state, of course I want to execute this function and close the modal. Later, as I said, we'll also use the backdrop in other places, and then I don't want to toggle the movie modal, but do something else when we click the backdrop. So therefore, I will actually add a brand new function here, which I'll name backdrop click handler. And this function will then actually do everything that should be done when the backdrop is clicked. So here I will call toggle movie modal and therefore connect this here so that at the moment we still close that, but we got more flexibility to also do other things when this is clicked. Now with this change already, of course, if we reload, click here, click the backdrop, this closes, and we can repeat this process as often as we want. So that's great. Now, of course, it would also be nice if we could click this cancel button to close this. And for that, let's have a look at the HTML code again. It's this cancel button I'm talking about. It doesn't have an ID and still will need a way of selecting it. And now here, of course, you can be very creative. Now you could think about getting access to the Modal Actions div here, but we'll also have this in another place later. Now, since this is the first occurrence of this, we could actually use it and select it with query selector and then select the first element child, which is this cancel button. And here, this relation is also unlikely to change. So using a DOM traversal technique like first element child should work here. Or we could also try to select it by selecting the add modal here and then select the first button which we find in there, or a button with these classes here with the button passive class, because this is the only button with the button passive class in the add modal div here. So that would be different ways of selecting it. Now you can certainly make arguments for the different approaches. Here I'll add a constant and name this cancel add movie button, because it's the button that cancels this add movie process. And now, as I said, there are different ways of selecting this. Now, actually, we already have access to the add movie modal here, so we can use that and then run a query on that. So we don't have to do it on the entire document. Since I'm searching for a button inside of that modal, we can just use add movie modal and then run a query here with query selector. And then here, I could run a query for the first element that has the button passive. So this class here, because this is the first and only button in this add movie modal, and it's the button I'm interested here with that class. I mean, it's the first and only button with that class. So now this gives us access to this cancel movie button here, cancel add movie button, and now we can add it here, event listener, click, and now I want to execute a function, of course, when we click this, maybe add it here, cancel add movie. You can, of course, pick any name you want here. And when this gets triggered, when this function gets executed, I want to call toggle movie modal because I want to close that movie modal. So here we can point at cancel add movie on our event listener. And with that done, if we save everything and we reload here and I click cancel, this also closes it. So now we get different ways of interacting with that. Now I would say it's time to make sure that we can also click add here and then have a look at all these input fields here, check what has been entered there, maybe even add a short check to see whether something valid was entered or not. So if it's empty or not, basically, and then take that information and add a new movie as a JavaScript object here in our script at first, but then later also as an element which we add here on our screen. The first step again is to get access to that add button here, and we can select this like we selected the cancel button, just with button success, or actually based on the cancel button, and then we take the next element sibling, which would be this add button. And here it's unlikely that another button gets added, so using this DOM traversal technique actually should be fine here, but using a query selector or assigning an ID to it, which you could do of course, that's also totally fine. Here, also to practice the DOM traversal, I'll add my confirm add movie button and use my cancel add movie button here, and then next element sibling, which will give me the, next element sibling, which is just this confirm add movie button. Now we can take that and add an event listener to this button as well here at the bottom. Add event listener, click. And I want to add an event listener here where I trigger a function where we then collect all the input and, try to do something with that. So I'll add a new function here, add movie. And actually, I'm not quite happy with the names I picked here. I named this here backdrop click handler. Here, I named these functions in a different way. And I mentioned earlier in the course that you should be consistent. And actually, I like this approach of having handler at the end of functions which are triggered by an event listener. Now for toggle movie modal, you could go either way because this also is a function which I call from inside my code. I also attach it to event listeners, so you could argue that I should add handler to it. You could argue that it makes sense to not add it because I also call it from other places. For backdrop click handler, there I didn't actually connect this here. I should have done that, of course. Yeah, that's a mistake. So there I connect this to the backdrop, and that has the right naming because this only is called upon a click listener. For cancel adding a movie, I should also add a handler here because I only call this, or I only connect this to an event listener as well. And for adding a movie here, I will also only call this when this button is clicked, so upon an event listener. So I will also name this add movie handler. So now these names should be fine and should be consistent. And whilst it is of course not the end of the world if you make a mistake there, you should try to be consistent here, because that ultimately improves readability of your code and makes it easier to understand. So with that, we got the add movie handler function connected to that confirm add movie button. Now my goal is to select all the values that were added by the user. So the inputs to these three, inputs, validate them with a very basic validation where I just check whether they're empty. And for this input here, I want to check if the number that was entered is between 1 and 5. And then add a movie object in some array, which we also have to add in our script. So let's get access to these inputs here. And of course, you can select them in different ways. You could select them as a list by selecting the input element. You could select each one individually by its ID. Now to practice this list selection, which we haven't done thus far, I will actually add a new constant here, input, or just inputs, alternatively of course input elements, but I haven't used element before, so I'll not start now, just name this maybe user inputs. And then here, reach out to my add movie modal, and in there we can use query selector all to select all elements that meet this CSS selector. And here I'm selecting all elements with an input tag. So that of course will select these three inputs here. And as an alternative, you could also have used the more old school method of get elements by tag name input. That would also work and is also totally fine to be used, but I'll go with the query selector all method. So this gives me all these inputs here in an array-like object in such a node list. And therefore now we can use this here in add movie handler to retrieve the values from there. So there I want to get my title value, let's say, and I can get this from user inputs. And there the first element at index 0, that will be this title input, and the order is also unlikely to change, so accessing it by index like this should be fine. You could of course also come up with more dynamic solutions, but actually we would need a bit more JavaScript knowledge to implement a more dynamic solution, and this solution is absolutely fine. So here I select the first element and then dot value, because this will be an input element, so we will have a value property there. Duplicate this and add a image URL value here, which is the value of the second input, because that is our image URL input. And the third input is this rating. So duplicate this once more. And there we have the rating value. Select the third element with index 2 therefore and get that value. And now with that, I just want to quickly check the input values here and check if title value, and now there's a helpful method you can call on strings, the .trim method. This will remove excess white space at the beginning and at the end of the input, so that if you enter something like this, which essentially is an empty value, but technically is not an empty string, that if you enter something like this, it still is treated as an empty string, because trim will remove such excess white space, so white space which is not between two words. So if the trimmed value, so the value which is corrected for all excess white space, if that is equal to an empty string, or if image URL value, if we trim that, is equal to an empty string, or if the rating value, if we trim that, is equal to an empty string, then we certainly have an invalid input, though I also want to add another condition for which I want to check. So, or if rating value is smaller than 1, and I can compare it to a number here, it will hold a string, but it will then try to coerce it to a number. Alternatively, of course, to be super clear, we can add a plus or parse int here to convert this to a number, and it will not add a check that checks whether this can be converted to a number. You could do that as well. You could check if parse int rating value returns not a number, and then also throw an error here. I'll omit this check here. Also because this type of input makes it hard to enter non-number content due to the way it's configured, at least on modern browsers. So we'll omit this check, but I want to check for numbers that are too small or that are too high, greater than 5. So if any of that is the case, I will throw an alert and say, please enter valid values, rating between 1 and 5. And of course, you could also build your own modal for that. I'll just use that built-in alert and thereafter return so that we don't continue with the function execution. If we give that a quick try here and I reload and I try to click add here without anything entered, we get that alert here. If I enter a movie, but I enter nothing for the URL, still get an error, still get an error. Entering 6 here, still get an error. Entering -2 here, still get an error. And entering a value between 1 and 5, like 3, well, now we don't get an error. So now is the part where we can continue and then use these results. Of course, you could also check if that really is a valid URL, but that's something I don't really want to focus on right now. It's also not really the focus of this module. So now that we collected all these inputs here, I want to store them. So we'll add a new constant, movies, and that will be an empty array initially. And I want to add objects to that array where each object represents a movie. That will not on its own make it visible on the screen, but you often in the applications you build also want to manage your data here in JavaScript and not just as HTML elements on the screen, so that you also can work with them here in JavaScript and not always need to select elements on the DOM and work with that, because that is not great for performance and also means that you need to write unnecessary code. So here, after checking the inputs, I want to add an element to movies, and that will be my new movie, which is a JavaScript object here. And in this JavaScript object, I want to have, let's say, the title, and there I'll use the title value. I want to have the image, and that will be the image URL value. And I want to add the rating, and that will be the rating value. Of course, which key names you pick here, title, image, rating, that is totally up to you. Well, and now we can reach out to the movies array we just added and push the new movie onto that array. That will add it there. Now we can console log movies here to see whether that worked. And now I also want to close my modal, and therefore we can of course call toggle movie modal here. Now with that saved, if we go back, reload here, and now try this out and add this awesome movie, JavaScript, the complete guide here. Some image, later I will add a real URL here. Right now we don't have a place to show the image anyway, so doesn't matter. And then here a rating of 5, and I click add. Indeed here we see an array, the modal also closed, and in there we got this object with the data we entered. Now a problem we'll have is that if I open this again, our old input is still there. The same, by the way, if we enter something and then we decide to cancel, what we entered is still there. So typically when we cancel and also when we succeed, we want to clear the inputs. And that is therefore something I also want to implement here. I'll add a new function, clear inputs or clear movie inputs. And in this function, I just want to use my inputs here, so the elements stored in the user inputs constant, and clear the value. Now for that, we can say user inputs 0 value equal to an empty string. That simply sets the value back to an empty string, and that's exactly what I want. Or a more dynamic solution, we add a for loop and go through all the user inputs of user inputs. So we loop through all these user input elements, and then for each of those, we say user input value equal to an empty string. That also works, of course, because user inputs is an array or an array-like object, a node list full of input elements. Here we then loop through all input elements, and we set this to be empty. So now we can use this here in the cancel movie handler. There I'm going to call clear movie input. And in the add movie handler, there after toggling this, I also want to call clear movie input. Now with that, if we save that and reload, if we enter something there and we click cancel and I add this again or click this again, this is gone. And if I try it again, JavaScript, the complete guide, some image. So if I try adding this again, then if I click this again, it's also gone. So now clearing works, storing it here in memory works in case you would want to work with it there. Now, of course, it would also be nice to output it here on the screen. Now, outputting movies on the screen involves two parts. For one, I want to update the UI and, for example, remove this box here whenever we have movies. In addition, of course, I want to add movie elements to this unordered list, which I have here at the bottom. So I will need to select this section here and dynamically remove it from the DOM or simply hide it if we have movies, and then add the movie here. So for that, there are different ways of doing this. As always, I will add a new function here. Let's say at the very top, but it's really up to you where you add this. And you could name it update UI, because in the end, that's what this function will be there for. And here I want to check the length of the movies array. And if it's longer than 0, so if it's not empty, then I want to get rid of this section. Otherwise, I want to add the section again. So we'll need access to that section. Conveniently, it has an ID by which we could select it. So therefore, in app.js, we can add a new constant here. Entry text section, or whatever you want to name it, and use document get element by ID and use that ID here to get access to that entire section. And then here I'll add a check and check if movie's length is equal to 0, so if it's empty, then I want to show it, else we can go to the entry text section here and add a style where we set display to none, for example. I have no CSS class which I could toggle here, so we can use good old inline styles to set this to none. If the length of the movies is 0, then I want to set this to block. Now update UI should be executed whenever we added a movie. So here I will call update UI. And that alone should already have the effect that if I quickly add some input here and I click add, this box is gone. It's not technically gone. If we have a look at the elements, we see at the bottom in main, it's still there in the DOM, but I added this inline style. So that's working. Now let's also make sure we add the movie element to the screen so that we can see a list of movies. And for that, I'll add yet another new function, which I'll name add new movie element or render new movie element to make it really clear that this will be a function that impacts the DOM and what we see on the screen. Name is up to you. And now to this function, I expect to get some inputs, my movie object, for example, or the individual parts I need. For example, the title, the image, URL, and the rating. And then with that, we can render this new element here. Because now with that here, we can create a new element, new movie element. And here I'll name this element to make it really clear that here I hold that new movie element. And create it with the help of document create element and then li, because I'm going to inject it, I'm going to insert it in an unordered list, and semantically you should have list items, li elements in such lists. So that creates an empty list item in the end. Now on this list item, new movie element, we can add a class, and I can do this with class name because I don't need to toggle it or anything like that. I just want to add hard-coded class names here, and that's movie-element, a class which you'll find in app CSS. Here, this class will basically style these elements in the list. So I add this here to the movie element, to the new movie element. And now, new movie element, of course, also should have some content inside of it. Not just a list item with some text, but actually with some structured HTML content. And that will be content with which I don't need to interact, where I don't need to assign specific classes that change dynamically. So we can just use inner HTML to set the HTML content of that newly created element. That, by the way, is something we haven't done before. We certainly created elements, but we haven't created an element to then change its inner HTML content. But of course, that's possible. It's a regular DOM object in the end. So of course, you can also change and analyze and do whatever you want its inner HTML content. So here I'll set this to a string, and I'll use backticks so that I can actually use a multi-line string here. Simply for readability, because it allows me to write HTML, which is easier to read. And now here, inside of that movie, I will add HTML content where I have a div. And now that's why I use backticks. I can write it like this, which is easier to read. A div which should have a class, or actually a class, of movie-element__image. That simply is a class defined in app CSS. And in there, I want to have an image element, which has a source where, and now another advantage of the backticks, where we can inject the value dynamically, which of course should be our image URL, and also alt text for accessibility, where we use the title as an alt text, let's say. We don't need to assign any class here. I also want to have a sibling div to that first div, which will also get a class. This gets a class of movie-element__info. Make sure you never forget a closing quote here, because that will be HTML code which is parsed in the end. Hence, it should be valid HTML code. And in that div here, we can add a h2 tag, opening and closing, of course, where I then inject the title. So I'm using the parameters I'm getting here. And then also a paragraph opening and closing. No CSS classes need to be attached, where I set rating and then /5 stars, so that it shows as rating of a maximum of 5 stars. So that's the inner HTML of the movie element. And now we can get access to that list here, to that unordered list, which conveniently also has an ID, which makes selecting it quite easy, and then add that element. Now for this, we can again register or select this list up there, but actually I'll only need it here in render movie element. So here I can get my list root, or however you want to call it, and I get it with document get element by ID, and select the movie list here in this place. And now this constant, which I can use in this function, since it's a local constant to this function, can be used to then append or append child, depending on the browser support you need, the new movie element. So this now adds the new movie element to our list of movies. If we now do that, we just need to make sure that this gets called when we add a new movie. So here in add movie handler, I want to call render new movie element, and I need to forward my data, which I get from new movie. I want to forward the title. I want to forward the image. And I also want to forward the rating, of course, to that render movie element function. So with that, make sure to reload the page. And then let's add a new movie. JavaScript, the complete guide. Now I pick the image on Google image search for JavaScript. Give it a rating, click add. And here it is. Here is our new element added to the list. And of course, we can add another element, another movie, and I'll just use the same image. Of course, you could use a different image, give it a rating of 4. And this now also looks quite decent here. So now we render these elements, we show them in the list. We also manage them here in our array, which we don't really need for anything else, but just so that we also have it here, doesn't hurt to manage this. In other projects, you might need this JavaScript data. Now, of course, I also want to make sure that we actually can remove elements by clicking on them. Now, to make sure that we can remove movies by clicking on them, we need to add a click listener. We need to add that click listener to our new movie element, which we in the end add here, right? So that's the first important step. So here, when we do create that new movie element, we need to add an event listener in exactly that place. So before I append my new movie element here, I want to add an event listener, a click listener, of course, and that click listener should toggle or should trigger a function that deletes that movie. So I'll add this function here, delete movie, not element, but movie in general. And I'll name it handler though, because I'll attach this to an event handler. So delete movie handler here, add it to this event listener. And now inside of delete movie handler, we need to do something. Now, the trickiest part here is to find out which element was clicked. Now, that will be easier once we know a bit more about events and that they actually help us with finding out which element was clicked. But we don't know this yet. For now, we can help ourselves here by binding a value here. You learned about bind. This allows us to pre-configure arguments that are received by the to-be-executed function here. And here you can pass it null as a value for this thing, which doesn't really matter to us. And now we need some unique identifier for that movie that's created. Now we don't have that yet, so let's actually expect a new argument here, maybe the first argument, which should be some ID, which we can bind here. Of course, currently we don't get that. So let's go to the place where a new movie is created in memory, here. And there, let's make sure we also create an ID for every movie. So here I'll add an ID property to the new movie object. And one ID we could generate here is math random, and then call toString on that to convert it to a string, which is not necessarily required, but I just want to have a string ID here. Now, of course, a random number is not really a unique ID. You can generate the exact same number twice, but for this demo, it will certainly do, and it's very unlikely that in this demo here, we end up with the same ID more than once. So now we can use that and pass it on here, new movie.id. And now, since we pass this on to render the new movie element, and there we in the end bind this to the delete movie handler, we get this ID as an argument, movie ID here, in the delete movie handler. And now that we got the movie ID here, the question is, what can we do with it in this place? Well, we can use it to find that movie with that ID in the movies array, and the index the movie has in the movies array should be the index the movie in the end has, the movie element in the end has, in this list root, because we add elements in the same order to our movies array as we add them here in our list in the DOM. So the order and the indices should be the same, and therefore if we find out the index of the movie here in the movies array, that should also be the index we need to remove, or where we need to remove an item in our list here in the DOM. Now, to find the index of the movie with that ID here, movies, we will learn about more elegant solutions in the upcoming array section. For now, with the tools we know at this point, we can use a for loop and go through all movie elements here in the movies array with a normal for off loop, and then check if movie.id is equal to the movie ID we're getting here. And if that is equal, we know that's the movie we're looking for. That's the ID we need. So here I'll add a new variable, identified index, and this starts at 0, or just movie index, but shorter. And then we add one here at the end of each iteration. And here, if we got the right ID, we just break. So we stop the nearest loop, which is this loop, which means we exit out of the loop, and the movie index we have is clearly the index of the movie we need. By the way, using a for loop, a regular for loop instead of for off would have been an alternative, of course, for that. But since I also want to be able to use the movie index once the loop is finished, I go for this approach. And therefore now we know which movie index is the right index for that ID. Now we can use that to remove an element from our list of movies. So first of all, I want to remove it from my array here in JavaScript, which of course is not reflected in the DOM, but still this needs to be updated as well. And to remove an item from there, we can use a method which is available on arrays, the splice method. This takes an index as an input, movie index, and then the number of items you want to remove, and it will just do that. It will manipulate that array by removing that element at that index, and items after that element will simply move forward by one place. So the next item in line, the next element in this array, will get that index of the item we just deleted. So that's just the JavaScript code, of course. We also need to update our DOM. And for that, again, I need the list root. So I guess we could have set it up as a global constant, but since we only use it in 2 places, duplicating it here should also be fine. But also feel free, of course, to move this to a global level so that you only set the list root constant once there. I will again go for another local constant here in this delete movie handler. And now in this list root, we need to remove the element at that index. So we can reach out to list root children to get all the child elements. And then, of course, select the item with movie index. That should be the movie we want to delete. There we can call remove, as you learned, or the backwards compatible solution would be to use list root, remove child, and then go for list root and then select that child with that logic here. So both should work. Let's first of all give that more modern approach a try here. And since delete movie handler has been connected to the event listener, that should actually, in theory at least, all work. So if we reload here and I give this a try and enter JavaScript, the complete guide here, take that image which I used before, and then quickly add another entry here, more same image, but of course different text, so we'll be able to tell if the right one was deleted, and another like this. And now let's click on more, and this looks good. It's deleted here, and the other two are still there. If I click on JavaScript, this is deleted. If I add a new one, so that the array is printed again in JavaScript, we see this only has 2 elements. And yeah, that's another with a rating of 2, and here, this one with a rating of 3. So the right elements were deleted here, the DOM, and also in the JavaScript array. Now let's also try that other approach, which is more verbose, but also works on older browsers. If we now reload here and give this a try, JavaScript, the complete guide with this image, add it here, and add this, click on this here maybe. Yeah, that also works. Now I'll go for the shorter approach, but either of the two is fine. And this now also deletes elements. Now one important note, by the way, about this event listener, when a movie is deleted, that of course means that this event listener goes into the void and is redundant because the element is redundant. Does this create a memory leak? The answer is no. If you delete an object from the DOM and you have no reference to that object in your code anymore, which we don't have, then JavaScript or the browser will automatically clear everything that is related to that DOM object, including any event listeners. So it will clear the event listeners for you automatically. And the only references we have to that new movie element are here in this function, this constant new movie element. This points at this list item which holds that event listener. Now once the function execution is done, that means that this constant is not used anymore, and JavaScript detects this and therefore treats this object here, the list item here, as unreferenced. So when we then delete it in the DOM, it will be able to clear the event listener. That's just a side note so that you don't worry about that. Now, theoretically, our little application here is finished, but if you have a look at the HTML code, you'll see there is another modal in there which we are not using yet. And in the end here, I'm asking whether I'm sure that I want to delete an item. So in the end, I want to present this modal when we click the delete button here, and only if we click yes in that modal, I really want to delete the movie. So I want to have an extra confirmation step so that we don't accidentally delete a movie. Now, to make that work, we need to restructure our code a little bit. I'll add a new function, maybe here above delete movie handler, which I'll name delete movie. And in there, I expect to get that movie ID as well. And actually, this entire code here, that's just moved in here because I want to call the delete movie function from inside the delete movie handler. So call delete movie here with movie ID. But I only want to do that if we showed that modal and the answer has been yes. So I'll comment this out for now. And then here, I want to add the logic to, well, show that modal, show the backdrop, and also react to clicks on these buttons. So let's select that little modal here. And it has an ID of delete modal, which is quite convenient. So we can select it by that ID, and we can do that globally, or we just do it here in the delete movie handler because that's the only place where I will need it in the end. So in here, I can get access to my delete movie modal with document get element by ID for that delete modal ID. Now with it selected, I will use that delete movie modal here, use the class list property, and then add the visible class, We could use toggle, but this doesn't really make sense here. When this gets called, so when we just click the movie element, there is absolutely no way that this modal is currently shown. So toggling it to remove the visible class if it's currently there isn't really something that could ever happen. This modal can never be visible when this function executes, so we can only add this. Removing is not something that should ever make sense. I also want to toggle the backdrop so that we see that. And with that, if I save that, and we reload here, and we add our item here with this image, add, and I click here, indeed that modal opens up. Now there, of course, clicking the buttons doesn't do anything. Clicking the backdrop does something strange. The backdrop now actually shows us the other modal, so that's something we'll have to fix, and this modal doesn't disappear. So looks like we need to tweak our code a little bit. Now we're showing the other modal when I click the backdrop of this first modal, because whenever we click the backdrop, in the end what happens is that the backdrop click handler executes, and this calls toggle movie modal, which will of course show that other movie modal if it was currently not shown. Previously that wasn't a problem, because there the only thing that added a backdrop was that movie modal, so toggling it would always remove it. Now other things can add that backdrop, and then clicking that will actually show the movie modal. So to work around that, we need to change our code a little bit and actually get rid of the toggle functionality, which worked before but doesn't anymore, and instead add a close movie modal function here, which will just go ahead and use add movie modal class list and then remove the visible class here and rename toggle movie modal here to add movie modal or to show movie modal. And then here we use add instead of toggle. Now that of course means we need to change all places where I used toggle movie modal. Here, when I canceled adding a movie, I want to close the movie modal. If we scroll down further here, when we added a new movie, I also want to close the movie modal. If we scroll down further, when we click the backdrop, I want to close the movie modal, never open it. And on the other end here, when we're clicking the start add movie button, I want to show my movie modal. And here we could therefore also add a handler function, but since show movie modal could theoretically also be called from other places, I'll keep that name, but it's up to you whether you want to keep it or not. So now with that restructured, we should be good regarding that behavior of that other modal showing up suddenly. Now I also want to make sure, of course, that clicking the backdrop closes our confirm deletion modal though. So this modal, that this is closed if we click the backdrop there. And to make sure that this is possible, I will actually grab this constant, delete movie modal, and move it up to the other constants so that this is globally available and not just in this function here, not just in the delete movie handler, because that allows us to add another function, cancel movie deletion, and in there I want to toggle the backdrop, and I also want to reach out to the delete movie modal, and there on the CSS classes I want to remove the visible class to close the modal and get rid of the backdrop. And now cancel movie deletion is something that should be called from inside backdrop click handler. We could of course also, to be in line with the other names I guess, name it close movie deletion modal. Just a very long name, but might be clearer. So close movie deletion modal, of course that's now also what I should rename this function to. And now with that, if we save that and we reload, and we give this another try, enter something here, now I have the backdrop open up after clicking add. So there's something wrong. If I add a new movie, let's have a look. Add movie handler, close movie modal. Yeah, I of course also need to toggle the backdrop here now. So now if we save that, give this another try and reload, enter something here, this works. And if I now click on this, we got this handler. And if I click on the backdrop, it just closes now. This opens again. So that's now all working. So this looks good. Now let's make sure that the buttons inside of the confirm deletion modal also do something. So inside of the delete movie handler function here, I want to make sure that we also work with the buttons that we show in that modal. That would be that no and that yes button. Now again, we can use button passive and button danger, these CSS classes inside of the delete modal div here, to select these buttons. So if I go to app.js, in here, I want to add handlers to these buttons. So delete movie modal, and then query selector, CSS class button dash dash passive. That's my cancel button. And here, that's the danger button. That's the yes button. Now we just need to add event listeners here. And of course, you could store these selected buttons in constants here. You can use global constants. I'll go with local ones because I really only need it in this function here. So I'll name this cancel deletion button, because that's what this button will do. And here add another constant which we could name confirm deletion button. Now we can add event listeners, cancel deletion button. There I will add an event listener for click event and add an anonymous function. You could of course also go for a named function if you prefer to, but here an anonymous function where I call close movie deletion modal, like that. Therefore we can actually also just point at this movie deletion modal function like this, because we don't need to do anything else with it. And nothing else needs to be done when this button is clicked. So if we now save that and we go back here, reload, and add a new movie like that, click on it here and click no, this closes this, just as if we click on the backdrop. So this works. Now if I click yes, then I really want to delete it. So then I want to execute delete movie. So we also need to add a listener here, confirm deletion button, and there I'll add an event listener where upon a click I want to execute delete movie in the end. And here we need to bind null and then the movie ID so that we forward that movie ID in the end, so that the right movie gets deleted eventually. And I can get rid of this comment. Now, as mentioned before, you could rename these functions which are triggering here to handler functions, because they're now only executed upon handlers. For deleting, I will definitely do that. Delete movie handler. For closing the movie deletion modal, I'll not do it because we actually can trigger this from other places as well, like here in the backdrop click handler function. So with that, let's give it another try. Let's save that and do a full reload here. And now I get an error in line 44. Identifier delete movie handler has already been declared. So look, line 44 complains about delete movie handler. Oh yeah, of course, I'm duplicating the name now. So this here makes sense to be called delete movie handler, because this really will do the deletion. This will just confirm or check whether you want to continue. So I'll name this start delete movie handler, because in the end here we start that deletion process. And now we just need to go down to render a new movie element and there connect us to the start delete movie handler, this click listener here. So now we got rid of that duplication. If we now reload, there are no errors. And now let's give it a try. Let's add JavaScript, the complete guide here, like this, add it, then also add something else, clearing the input when I cancel. When I click the backdrop, by the way, it doesn't work, as I see. Clicking cancel here also doesn't get rid of the backdrops there, so there still are some errors which we should get rid of. We'll do so soon, but now here I cancel, now I confirm, and now everything's gone. So that didn't really work. We still have a couple of bugs which we need to fix. Let's make sure we do fix them now. So first things first, if we reload, one problem we have is if I enter something here and I click cancel, the backdrop doesn't close. If I enter something here and I click the backdrop, everything closes, but my input is not cleared. So there are a couple of things I want to change here. For one, clearing that input. We got that clear movie input function, and we call that when the cancel at movie handler is called. Well, in the end, of course, I also want to call this whenever we close the backdrop. Of course, that also therefore calls this function if we close the other modal, but since that is the only other use case we have in this app, calling it like this will be okay. So that should fix this error, that if we enter something here and we click the backdrop, the content was still there. This works. Now, however, we have another issue. If I click cancel, the backdrop doesn't close. Now, let's have a look at what happens when I click that cancel button. Cancel add movie button here fires the cancel add movie handler, and in there I close the movie modal, I clear the movie input. Well, in close movie modal, if I scroll up, I indeed don't toggle the backdrop. So here I need to toggle the backdrop instead. So now this should make sure that when I do click cancel here, we also clear the backdrop. Now, another issue we had was that if I do add movies here, let's say 2, and I click on one, and I confirm deletion, now I delete it, but I get an error, and that does not close. And previously, if we reload here, if we add 2 items here, this one, and then, and then this one here, right? If I add 2 of them, and I click on the first one, and cancel, and click on the second one, and click yes, both are gone. So this never closes, and the deletion process also isn't correct. Now, regarding the modal which doesn't close when we confirm deletion, for that we can just go to our delete movie handler, which is in the end triggered when we really want to get rid of everything, and there we just have to call close movie deletion modal, and therefore, even though it would work in this order as well, because everything is parsed before this will be executed for the first time, I will move that up above that so that I have a structure where I have the functions that I call above the functions where I need them. Therefore, actually, I will, even though it's not strictly required, also move toggle backdrop up a bit, cut that, and add toggle backdrop here at the top. But that's not the main thing. But now we should close the movie deletion modal once we delete the movie. But still we got some error here in our logic, as it seems. It seems like we're deleting the wrong item sometimes. Let me show you again. Now if we reload here, and we add a movie, let's say a single movie, and I click on it, and I confirm this, it works. If I add 2 movies here, first one, second one, and I click on the second one, and click yes, this also works. If I add 2 movies here, like that, and then here like this, and I click on the first one and delete it, this now works. So let's see. It seems to fail if I have more movies, like this, and we then click on one, cancel this, and then delete the other one. Now this clearly does not behave in the way it should. Now what's the problem here? The problem has something to do with the start delete movie handler. There I set up these event listeners, and the problem is, if we have a movie here, it even occurs with only one movie, and I cancel deletion, and then I delete. Here I get another error. The error source is the same, or the problem we have here is actually the same as the problem that causes multiple items to be deleted. Whenever I start the deletion process, we add an event listener for both buttons, right? Now when I cancel, we of course execute this event listener, or this function here, and not the other one. If I then click on the same movie again, or even on a different movie, the problem is that we add new listeners to the cancel and confirm deletion buttons, but the old listeners are also still there. You must not forget that the DOM object, these buttons, the underlying DOM objects, are never removed, so the event listeners are of course never cleared. So that means that if we then click confirm on that newly opened modal, all event listeners we executed in the past will execute, even the ones for the other movie we might have clicked on before. And if we only have one movie and we open and close this confirm modal multiple times, like I can do it here, then we basically add more and more listeners to the confirm button. And if I then click yes, I get as many error messages here complaining that you can't remove that element anymore because it's gone already, as you open this modal. So if I opened the modal 5 times, I get 4 error messages here because one time clicking confirm succeeded and deleted the item, but the other 4 event listeners, which also were added, go into the void. They execute their function, try to delete the element, but the element is gone. With multiple movies, I might have clicked on multiple movies, and therefore all these event listeners are registered, and then if I click yes on some movie, all event listeners execute. So what's the solution here? Well, we need to clear the existing event listeners. Now the problem is, there is a confirm deletion button, and of course also for the other button, remove event listener function, but this takes the event for which you want to remove a listener, and then the function which you executed on your event listener. So in this case of the confirm deletion button, this delete movie handler function, but now here, since I use bind, this actually returns a new function. Now you might think, no problem, I call bind here up again, but this will actually return a new function object, and because, as you know, 2 objects, even if they hold the same content, which here is not even guaranteed because the movie ID might be different, but even if it would be the same content, objects and therefore all the functions are different. So this would look for an event listener with this function object, which is not the same as this event listener. So this would not work for this delete movie handler function. Now, the good news is for cancel deletion, so for this button it will work because there I'm not using bind. So here if I click and then point at close movie deletion modal, we use exactly the same function object because we don't create a new one. We point at this global object instead, which is created once when the script runs at the beginning. And therefore this will work. So for the cancel deletion button, we're good. We clear an existing event listener before we add a new one. Now for confirm deletion button, as I said, this will not work. And I can actually show this to you if we save that. We give it a try. And we add a new movie here. And I click on this multiple times. You see we still get the same error. So that didn't work. So let's comment it out. So for the confirm deletion button, we need a workaround. And a workaround we can use here, even though it's a bit hacky for sure, but it will work, is to simply recreate that deletion button. Because if we do that, we get rid of the old DOM object. And with that, all existing event listeners will be removed if you hold no other references at this button, which we don't. We only point at the button here instead of this function. So whenever this function execution is done, these constants will go into the void. And therefore, garbage collection can then kick in and actually get rid of these old event listeners. So what does this mean? It means that before I add event listeners here, I want to swap that deletion button, so that I always have a brand new button when that function executes again. To do this, I simply say confirm deletion button and call replace with to replace this with a new node, and I want to replace it with confirm deletion button clone node. True, to make a deep clone. And with that, we clone this confirm deletion button and replace the existing one with it. So the DOM object is created with a clone and therefore with a new object, which means all listeners can be deleted. And a deep clone is required here, by the way. Otherwise, the text inside of the button will not be cloned. So now this will replace that button. Bit hacky for sure, but at least now we have a way of practicing clone node and replace with. And since it replaces the button, this confirm deletion button reference, which we have here, of course, will not work anymore. That's the old button, which we now removed from the DOM. Hence, I will actually change this to be a variable and then simply repeat that selection process after I swap this so that I get access to the new button thereafter. And here I get access so that I attach the listener to the right button. With that, if we go back and we reload this and we try JavaScript, the complete guide here, if we now click on this a couple of times and cancel, and then click yes, this seems to work without issues. Now let's also try multiple items here, multiple elements which we can add. And click on the first one, cancel, click on the second one, and now the first one indeed survived. And this now should be a setup that works, and that works just fine, no matter how often you click on something and what you do with it, because now we're attaching this correctly with this little workaround here, but that simply is a nice way of practicing this again, and it helps us solve the problem of having too many event listeners here. Now, needless to say that JavaScript, of course, also holds other ways of solving this, but I found it nice to also, again, play and work with, replace with, and clone Node. And other ways of solving this would actually involve techniques and features of JavaScript we haven't really learned about yet. Hence, this approach. We will, however, learn more about events and also about functions and so on throughout the course, so that we can handle this entire deletion process or similar cases in a more elegant way in the future. Nonetheless, this is this finished and working application here. Well, almost. One thing is missing. Do you know which? Well, it's a minor thing, but if I have no items anymore, I want to bring back this section here at the bottom. So we have this update UI function where we do perform this check whether we want to show it or not. So all we need to do is call update UI whenever we deleted a movie. So here I want to call update UI, and with that called, let's give it a try. Let's reload. Try JavaScript, the complete guide again, like this. Open this, close it, click yes, and our text here is back. If I add another item, it of course should be gone again. Yes, that all works. So now we're finished with this app. So that's it for this tiny application. Quite some code which we wrote. Also, of course, verbose code, because I wanted to practice what we learned in this module, show you different alternatives of doing certain things. As we evolve through this course, there certainly are some things we can solve in a more elegant way, but that's certainly not to mean that what you learned here is not something you would use. Indeed, what you learned here is the bread and butter of working with JavaScript. Being able to select elements in different ways, being able to traverse the DOM, select child elements, change styles, assign classes, remove and add elements, swap elements. These are all things which you will need in almost any real JavaScript application you're going to build. So this here is super important and shows you many ways of adding elements, of working with elements in the DOM. Now, throughout this entire module, you learned about many ways of selecting elements, of deleting and adding them, of manipulating them. You learned about different types of nodes. You learned about the difference of attributes and properties, and many more important things. Now, I would definitely encourage you that you practice these things, that you simply play around with the different techniques. Create a simple HTML file and start selecting elements in different ways, start manipulating them, dive into MDN to find out what you can do with the HTML elements you got, what you can do with a button, what you can do with a div, and get a feeling for how you work with the DOM. We'll also dive into that again later to dive deeper into more advanced concepts, for example, where we dive into how to find out which size an element has and to move it around. But we already covered all the crucial fundamentals which you need to work with elements and manipulate a page whilst it's running in the browser.